Hello grade 12s, welcome to my channel and let us do some IEB question paper. I have not done an IEB question paper for maths, so here it is. I don't know when you guys are writing, but in any case you guys don't seem to need any form of help, so to speak. So yeah, the videos on your curriculum don't seem to do well for many content creators, so that already suggests not many of you do need any help in your curriculum. But hey, let's throw it in. There's one or two students who might benefit. Okay, so this is the two instructions to internalize. Of course, do adhere to the rest of the instructions, okay? So let's just get to this one and move. Question 1. Now we are told that point P with those coordinates, point Q with those coordinates, R with those coordinates are on the same straight line. So it means these points are collinear. Okay? And if they are collinear, it means the gradient between, say, P and Q should be equal to the gradient between we can say Q and R. Okay, great. So that is the essence of this statement, meaning the gradient between any two of those points would work. But I often like to draw a sketch so that I can see if my answers are suggesting I'm making a mistake or not. Alright guys, so what I often do, I do a near perfect sketch so that I can get my answers to make sense. Alright, so we're going to be answering A. So we know that literally the gradient between P and Q should be the gradient between Q and R, because these are all collinear points. You can say P, Q and R these are collinear points. Okay, so we can say y at P minus y at Q divided by x at P minus x at Q is going to be y at R minus y at Q divided by x at R minus x at Q. Now, y at P, it's A, minus y at Q, that's 4, divided by x at P, that's 2, minus 3, it's going to be plus 3, equals y at R is 8 minus 4, divided by 1 minus 3. Okay, so this implies that we've got A minus 4 divided by 5 equals 4 divided by 4. Okay, so we just cross multiply that 5 there. So this implies that A minus 4 is going to be 5 because that's 1. Therefore, A is 9. Does it make sense? Yes, this is above point R and it's not so far away. So we can accept that answer. Can you see, once we have a sketch, it can actually tell us when we are far off or we are making a mistake. So sometimes don't ignore the idea of doing a near perfect sketch to sort things out. We're scoring 3 marks. So this left, right hand side, and the final answer should be those 3 marks. Okay, let's get to B. Now B says S with those coordinates, T with those coordinates are joined by a straight line, meaning they are collinear as well. Determine the equation of a line that is perpendicular to ST and goes through the midpoint of S and T. So this is the perpendicular bisector of ST. Again, I prefer to see a sketch before I can carry on. All right, guys, so there is our sketch. It's a near perfect sketch which you guys need to be masters of. So this is the perpendicular bisect. I'm just going to write it PB. And as we can see, we need the coordinates of M, the midpoint. Then we can use that property that these two are perpendicular and sort it out. And then again, this can help us to decide if our answer is indeed correct or not. So what we can say is that we know that we let M be the midpoint of ST. Okay, that is very important because we didn't talk about that point M. So we're going to say M is going to be like so: x at S plus x at T divided by 2 is 2y at S plus y at T divided by 2. Okay, this implies M, it's x at S, which is 4 minus 2 divided by 2 is 2. Y at S is 8 plus 6 divided by 2. Okay. Now, what are we doing? We know that our M is going to be, this is 2 divided by 2, that's 1. That's 14 by 2, that's 7. Okay. Does this point make any sense? Yes, this point is before this 2 there. So it's okay to say that would be perhaps 1. The y value is in between 8 and 6. So that should be okay. Now what are we doing? We want the gradient. We know that the gradient of the perpendicular bisector, okay, multiplied by the gradient of ST should be minus 1. Okay. Now this implies that the gradient of the perpendicular bisector into, we can just jump in here, y at S is 8 minus y at T, which is 6, divided by x at S is 4 minus, it's going to be like that. So we can say therefore the gradient of the perpendicular bisector is, now this is 2 over 6, which is 1 over 3, so that becomes minus 3. Okay, that's a fairly steep negative gradient, so I can take that. Say then PB, maybe here we might want to introduce this one and say this is the perpendicular bisector, in case someone doesn't know, is such that y equals 3x plus c. Now through point M, which is 1 and 7, oops, this is suggesting that 7 is minus 3 into 1 plus c. Therefore our c is going to be 10. Therefore y is minus 3x plus 10. Okay, nice and easy. Again, if we look at our sketch, we can see that this is 8, so 10 is not so far away from there. So we can take that. We can take that. All right, so this was a nice question again. So we get a mark for this. We get a mark for the gradient. Get a mark for the substitution. We get a mark for the final answer. That, I believe, is how those marks are scored. But you can look at the marking guidelines formally to find out exactly how the marks are distributed there. All right, so yeah, just be careful. The numbering here is weird, you know. So it's one of the ridiculous markings. Is it markings? No, ridiculous numberings you can ever see. So yeah, let's have a look at it. In the diagram below, CBA is drawn with C on the y-axis. Now, if that is the y-axis, it means that is the y-intercept. So we know that x is 0 there and some y value. And then A on the x-axis, it means A is some x value and some 0 y value, because that's an x-intercept. Okay. Now point D with those coordinates lies on CA, and E with those coordinates lies on CB. Not a problem. And then we have the equation of AB. So now this equation is best written y equals 2x minus 24. That is the best way. And from there, if we work out the x-intercept, we put y as 0, so x would come out as 12, okay? And then we look at the equation of CB, which is that line. Again, it's best if we write this line like y equals 1/7 of x plus 14 by 7, that's a 2. So this already gives us the y-intercept there, that it's a 2, okay? But remember, all of these things, it's just you and I simplifying our lives. We need to use these in the right context, but we're just wanting to make ourselves aware of what we are dealing with. Now, the first question says, prove that ED is parallel to AB. Now, we can clearly see that the gradient of AB comes out as 2, and we've got 2 points on ED, so we can sort that out. But we can start by saying, well, given, oh, now you see this numbering, it's catching me again. We can say given that AB is like this, y minus 2x plus 24 equal to 0, implies that y is equal to 2x minus 24. You can say therefore the gradient of AB is a 2. Very important to discover that. Can you see, we still need to show the examiner what our thinking is, or at least our marker for that matter. Okay, now what are we trying to do? We can say, well, also we know that the gradient of ED is going to be y at D minus y at E divided by x at D minus x at E. This is going to be y at D, that's 1, minus 3, divided by x at D, that's 6, minus 7. And this gives us minus 2 divided by minus 1 is a 2. We can say, therefore, ED must definitely be parallel to AB. The reason is that MAB is equal to MED equal to 2. Okay, that is not so bad. Okay, let's look at it. How many marks? 3 marks. Technically, discovering that was key, the substitution and that answer. The final answer was volunteered, but we just needed to prove it with those calculations. All right, not a big deal. We're doing that. So here's the next question. It says we need to determine the if D is the midpoint of CA. Okay. And we just proved that those two are parallel. Okay. Now, obviously, the midpoint theorem will tell us that this side must be equal to that side, because in a triangle, if one line is drawn parallel to the other side such that it cuts the one side in half, the opposite side will also be cut in half. Great. Now it says determine the coordinates of B. So we can use this property of the midpoint theorem, triangles, or we can clearly see that B is the point of intersection of AB and CB. And we've got 2 equations, so we can solve simultaneously. So however you want to see that, we can do it. So let's say 2 here. What do we know? we will know and accept that essentially, what are we going to say? Well. We can say, okay, all right, okay. We can say safely, given that CB is such that 7y is x plus 14. This implies that y is 1/7 of x plus 2. Therefore, point C is going to be 0 and 2. This is the y-intercept. Okay? Nice. I think that is important. We need to justify that too, because I want to use that midpoint theorem stories. So we can say, well, however, we know that point E with these coordinates 7 and 3 is the midpoint. Okay, let's start off nicely and make sure. However, point E with 7 and 3 is the midpoint of CB. Right. Why? This is the midpoint theorem of triangles with ED parallel to AB in triangle ABC. Okay, trying to be as comprehensive as possible here, because remember, you need to be in a conversation with the person who is marking, because remember, the marking guidelines by the examiner may not have explored that characteristic. But now, instead of surprising the marker with something different, and now they're not so sure if this is correct, you need to be clear so that they can follow you nicely. So what are we doing here? We can say now we appreciate that B is going to be such that x at B plus x at C over 2 must give us the x at the midpoint. Likewise, y at B plus y at C divided by 2 should give us the y at the midpoint. This implies that B is going to be x at B, which is what we want, plus the x at C is 0, divided by 2 should give us 7. Likewise, y at B plus y at C is 2, divided by 2 should give us 3. So therefore, point B is. Now the gymnastics here is just to cross multiply the 2 there. Right, so that's going to be 14 into, we'll do the same here, we cross multiply and then we transpose. What do we get? This is 6 minus 2, that's 4. Okay, nice and easy. Great stuff. So we can appreciate that. That is what we can do. Okay, so let's just prove this one if it is correct using simultaneous equations. So we know that 2x minus 14 is equal to 1/7 of x plus 2. If we move x to the other side, 14 to the other side, we end up with this situation of Wait, that was 24, not 14. Goodness. Okay, so 7 that side, we end up with 7 by 2. That's 14 minus 1. That would be 13 over 7. X equals 26. Now 7 can cross multiply. The multiples of 26 can divide 13. So let's see. So we have 7 times 26 divided by 13 gives us 14. Okay. So we can see that x here becomes 14. And therefore our y is going to be 2 into 14 minus 24. That's 28 minus 24. That's 4. Therefore b is 14 and 4. Okay. So even using the simultaneous equation technique, we still get the answer. So we know we are good. So how do we score these 4 marks? Of course, getting this point is a mark. And using the midpoint theorem here, that's second mark. Then those 2. That is how we score these 4 marks. Nice and easy. All right, so let's move on to the third question. The third question says, we need to find the size of CBA. This is this point right here, okay? Now we know the coordinates here. It's 14 and 7. We know that it's 0 and 2. Well, we know that this is 12 and 0, but we did not show it. So how are we going to find this? Now, what I'm looking at is this. So guys, what I'm saying is that if I use this triangle, because now I've got all the points, I can look for this angle. And that angle is definitely equal to that, right? Because we proved these 2 lines are parallel. Okay? So now those are corresponding angles. So we can do that. Or we can find the x-intercept here. And then we can do the whole side, that whole side. But we can use the cosine rule, because the cosine rule will use the side opposite that angle. So we need this side. We need that side. We also need that side. So that is what I am going to do. I'm going to say in triangle CDE. What do we see there? We will appreciate that technically CD is going to be the square root of x. In fact, here guys, we just want to jump in. We don't want to waste time, do we? It's going to be the x at D, which is 6, minus x at C, that's 0, all squared, plus y at D, that's 1, minus 2, all squared. So that we just want to jump in, because it's a lot of unnecessary work there, but the final result is good because it takes us where we want to go. So CD is square root 37 units, okay? And then we want CE. It's going to be the x at E, which is 7 minus that is C, 0 all squared, plus the y at E, that's a 3 minus 2 all squared. So let's sort it out. So we have so I'm getting 5 root 2 units, okay? Now we want ED. This is just labor intensive, that's all. ED, we can take x at E, which is 7 minus 6 all squared plus 3 minus 1 all squared. What is that? So that's it. 7 minus 6 squared plus 3 minus 1 squared. That's square root 5. Okay. Units. Okay. Now this is just a lot of work, guys. That's all. Now we can set up the cosine rule. From here, we know that technically, maybe we can say, we know also that essentially CD squared is going to be equal to CE squared plus ED squared. Did we write ED? Yeah. Minus 2 times CE times ED cos of CED. Okay, this is the cosine rule. Okay, good. So we substitute. So this is square root 37 all squared equals CE is 5 root 2 all squared plus ED square root 5 all squared minus 2 into 5 root 2 into square root 5 times the cos of CED. Okay. Now we sort it out, we just clean it up nicely. This is 37 equals, this is 25 by 2, that's 50, plus 5 minus 2 by 5, that's 10. Set rules is going to be 5 by 2, that's 10, cos CED. Okay. Now we want our CED. We know that C cos, we know that cos of CED is going to be 37 minus, this is 55, divided by minus 10 root 10. Therefore, CED is going to be arc cos of 37 minus 55 divided by minus 10 root 10. What do we get? So shift cos of 37 minus 55 divided by minus 10 root 10. Okay, I'm getting 55.3 degrees to 1 decimal place. Remember the general rule, and do not forget that degree. If that degree is not there, okay, that's not the answer. What am I doing? That was a means to an end. It's not an end in itself. So we can say, however, okay, we can say, but we understand that basically the angle in question CBA is equal to CED. Okay? What is the reason? The reason is these are corresponding angles with ED parallel to AB. Okay? So therefore CBA is 55.3 degrees. That's the final answer. Okay, so either approach, looking at the bigger triangle or looking at the smaller triangle and then relating the angles, would still do more or less the same amount of work. So it's one of those annoying questions, but I think 5 marks is fair. So we get 1 mark, 1 mark, 1 mark. That's another mark. And then this relationship right there. That should be the 5 marks. Obviously, guys, you can check the formal marking guidelines to ensure that if this approach is featured in there, we can see how these marks were distributed according to the specification of the examiner. Either way, we have solved that problem. Okay, let's get to question 2. Now, question 2a, we are told that a parallelogram ABCD is such that the diagonal AC is 5 units, AB is 8 units, and CAD is 55 degrees. Okay, now we need to find the size of the angle ADC. This is this angle right here. Now, how will we find that angle? Well, if we look at this triangle nicely, we will see that that side is equal to that side. These are the opposite sides of a parallelogram. So this gives us 8 units also. And we can then apply the sine rule because we've got the angle in the side opposite it. We've got the angle in the side opposite it, and the angle is in question. So we can simply say, well, in triangle, say ACD. What do we see there? We know that CD is equal to AB, equal to 8 units. Now, what is the justification for that? These are the opposite sides of a parallelogram. They are always equal. We can say then, we know that sine of the angle in question, which is ADC, divided by the side opposite it, which is AC, should be equal to the sine of any other angle in that triangle. We are going to choose the CAD over the side opposite that would be CD. And where do we get this idea? It's the sine rule of triangles, isn't it? Yes, this implies that sine of ADC divided by AC is 5. It's going to be equal to the sine of 55 degrees divided by 8. Then we just simply cross multiply that 5. We will appreciate that sine of angle ADC is going to be 5 sine 55 degrees divided by 8. Therefore, angle ADC is going to be the arc sine of 5 sine 55 degrees divided by 8, which would give us what? We will find, okay, shift sine 5 into sine 55. So sometimes be very careful of the brackets here, folks. They can be very hurtful if someone is not aware. Many people have gotten wrong answers because of not knowing how to handle brackets. So it needs you to be meticulous. I'm getting 30,8 degrees. Remember, general instructions said 1 decimal place unless otherwise stated. So we were scoring 4 marks. Obviously, substituting into the sine rule is important in the answer. Now, that statement and its reason, I think, is the other 2 marks. So we should be scoring those 4 marks easily. Okay, the second part says we need to calculate the area of the parallelogram. Now, here we have a bit of a situation now because we don't know this side, we can't use this triangle. We don't know this side, but we can calculate this angle, right? We can actually calculate that angle and then use the area rule in that triangle. So all we need is this angle. So what are we going to do? So we will say, well, in the same triangle we just worked on, in triangle ACD, what are we getting? What are we getting? We are getting the fact that ACD plus angle CAD plus angle D should give us 180 degrees. This is the sum of three angles of a triangle. Right. This implies ACD plus 55 degrees plus 30,8 degrees should be equal to 180 degrees. Therefore, angle ACD is equal to, it's 180 degrees minus the sum of those two. So let's see, what is that? It's 94,2 degrees. We can say then area of ABCD is going to be equal to 2 times the area of triangle ACD. Right, because these triangles are congruent. So if we have the area of this triangle, we have the area of that. Nice and easy. There's many ways of looking at it. If we consider this as the base, this is the same as that. That could be the base. The height is between the parallel lines. So same base, same height, good. Or we can look at congruent triangles. This side is common. This side is equal to that. This one is equal to that. That angle is equal to that. Opposite angles of a parallelogram. So therefore, those are congruent. So there's many ways of justifying that, but we can just leave it for now and just move on. So this is 2 into half of AC times CD times the sine of ACD, the included angle. So this is 2 into 0,5 times 5 times 8 times sine of 94,2 degrees. Maybe it's too squashed in there. I don't like it. 2 into 0,5 times 5 times 8 times sine of 94,2 degrees. So what do we get? So we have 2 into 0,5 times 5 times 8 times sine of 94,2. Be careful of brackets, guys. Can be horrible. So I'm getting 39,9 to 2 decimal places square units, or units squared. This is it. Nice and easy. So how many marks was this? 4 marks. Nice. So this angle was key, and substitutions here, the answer. This is worth 3 marks, but I suppose knowing that we need to multiply this by 2, probably this is where the extra mark is. Okay. Nice and easy. Okay, so that is that for A. So let's go to B. So B, it's trigonometry. We are given 13 cos theta equals 5. This implies that cos theta is 5 over 13. So we know we want to do our terminal arm diagram. On the Cartesian plane, theta is an element of 180 and 360, but now this is positive, so it's in the fourth quadrant, okay? Okay, that would be the origin there. So this angle of ours is an angle like so. Okay, great. So the angle theta is this one. It's a reflex angle. Now cos is defined as adjacent over hypotenuse, the terminal arm. So we know x squared plus y squared equals r squared. From Pythagoras, 5 squared plus y squared is equal to 13 squared. Right, this implies that our y squared is going to be equal to 169 minus 25. It's 144. Therefore, y is going to be the negative version of it, minus 12. Okay, because y is negative in the fourth quadrant. Nice and easy. Okay, so we are ready to solve. Number 1. We need to find sine theta. Sine is opposite over hypotenuse. So we get a mark for that. We get a mark for that calculation there. That's how those 2 marks are scored. 2. We need to do cos of theta plus 45 degrees. Now this is equal to, this is a compound angle identity. The sign changes. Okay, so what do? Sine cos of theta is 5 over 13 into cos 45 from special angles. This is 1 over root 2. Minus sine theta here is minus 12 over 13 into 1 over the square root of 2 from our special angles, and then we sort it out. 5 times 1 is 5 divided by 13 root 2. The sign changes. It's going to be 12 over 13 root 2. Now we've got a common denominator, which is 13 root 2. So this is 5 plus 12. Now this becomes 17 over 13 root 2. Now that should be the answer for grade 12. But for grade 11s, you may be forced to rationalize that denominator. But also IEB, I'm not too sure. You might want to rationalize if that is the rule. So please be specific to the curriculum. So we just want to get rid of the radical in the denominator. So this is me and you multiplying by 1, which is special. So we get 17 root 2 divided by this by that is 2. 2 by 13 is 26. So I'm not too sure how IEB looks at it. Does it allow an irrational denominator or not? But either way, how many marks is this thing? 3 marks. Maybe you don't, maybe you do have to do that. But this expansion is a mark. The substitutions using special angles and the diagram, that's a mark, and the final answer. Whether it comes out, it's required like this. Of course, you will know what your curriculum says. And the best way to know what your curriculum says is to pay attention to what your teachers suggest usually in class. Okay, so this is us scoring our final 3 marks of these 13 marks. If this is the way, okay, if this is the way. Okay, let's get to question 3. Trig functions, nice and easy. Now, if we just look at this nicely, we'll appreciate that this is essentially an invisible one there. Now this means our amplitude, I'll just say amp is 1. Now this is saying our maximum is going to be 1, but remember this is shifted. So we're going to shift 1 unit, gives us 2. And then our minimum is going to be the negative version, but we shift it 1 unit, it goes to 0. And that tells us the range of this function. It's between 0 and 2 for an amplitude of 1. Okay, great. But now we still have yet another business here. Seeing that the coefficient of the angle is a 2. So what can we say about it? Now, we know that the period is going to be the standard cosine period divided by the coefficient of the angle. It gives us the new period. And from this period, we get to calculate intervals. It's going to be the period at hand divided by the 4 quadrants. That should give us 45 degrees. Now this tells us that between our critical values, which could be an x-intercept or a turning point, we should have 45 degrees between them. Okay, that's the main thing. Because if we capture those points, we can have the shape of the graph properly. Now, let's look at the tan graph. The tan graph is a standard tan graph, so the period here is going to be the standard tan period divided by the coefficient of the angle. This is 180 degrees. And also the interval is going to be the current period divided by the 4 quadrants. So it's going to be 45 degrees. So now these two are the same. So if they are the same, we don't have to worry. But when they are not the same, we need to divide one by the other to get a scaling factor that accommodates both graphs nicely. So now let's answer some questions. Okay, all right, okay. So A says write down the period of F. Okay, easy. We found it to be 180 degrees. 1 mark. B, we need to write down the 2 asymptotes of G. Now G is the standard tan graph, so we know that the asymptote is going to be at x equals 90 degrees, because that is undefined, and x is 270, which is 180 degrees ahead of 90. Sorry, it's 270, because the domain covers up to 270, so that's good. So we get those 2 marks, nice and easy. C says sketch the graphs of f and g on the same set of axes below. Label all intercepts with the axes, asymptotes, turning points and end points. Not a problem. Okay, let me just take that call. Okay guys, so looks like my call was not a true call. All right, okay, all right. So we'll need to label all these things. Now let's start. What are we going to do? We are going to do this. For the tan graph, we know that these are asymptotes. Okay, 270 is the asymptote as well. Nice. So we can just break them up. I would do it there, there, there. So that it's easy to see. Okay. This is for the 10 graph. Okay, let's draw some points. Now we know 10 of 0 is 0. It starts there. 10 of 45 is 1. And then it approaches the asymptote. We skip 90. 135 is going to be minus 1. 180 is going to be 1. 225 is 1. Then we get to the asymptote. So this is how the graph would look like. Okay guys, so there is our 10 graph. This is how it's going to look for that domain that we were given. Now if you look at the sine graph, the cosine graph, we know that cos of 0 is 1, but it goes one more unit up, so it starts there. Now cos of 45, it's double that, it's 90, so that would be 0. But now we add 1, we end up there. Cos of 90 by 2, that would be at 180. 180 we get minus 1. Then we shift it upward by 2 units. By 1 unit. We end up there. Now 135 by 2, that would be 270. So we get 0. 0 by 1. Upward. We get there. At 180, this is what we'd get at 360, which would be 1. But we're going 1 up. So that is the 1. 225, this would be the same as cos of 450. 450 is basically 360 plus 90. Now cos of 90 is 0. 0 plus 1, it gets us there. And then cos of 270 by 2, this is 500 and what? Is it 70, this is 140. Yeah, it's gonna be 540. So 540 would give us minus 1, right? Minus 1 plus 0, plus 1 is there. It takes us to 0. So this is how the cosine graph would look like. Okay guys, so those are the graphs. Nice and easy. So we can just say C graphs. But I'm just directing you into my sketch because I don't have the time. Great stuff. So let's look at D. D says use the graph to write down the general solution of x for the equation. Now this is when these two are equal. So we can see that, well, at 45 they are equal. So we can look at that point right there. So we can write here x is equal to 45 degrees plus k times 180 degrees, because that would be the 10 graph, where k is an element of integers. Now, they're also equal at 225. When k is 1, this is 180 plus 45, gives us 225. So this is good. We can stop it here. So we get a mark for the solution and the constraint maybe, or just the answer as a whole. This is an easy 11 marks. Okay, but remember, easy questions have a tendency to allow for mistakes. As you can see, you are getting caught out here. Somebody included 315. And if you find yourself drawing the graph all the way, you are dead, because this is you being caught out. Because the domain for us to draw this graph is this one. So be very careful. Easy questions have a tendency to mislead deliberately so that you can lose marks by not being careful. Okay, let's move on to question 4. Okay. Question 4, we have A. We need to find the general solution for this situation. So this is cos theta minus sine theta equal to 0. So this implies that we have cos theta equal to sine theta. We can divide by cos theta here. What do we get? 1 is equal to sine theta over cos theta. This implies that this is the same as the tan of theta equals 1. This implies that theta is going to be arc tan of 1 plus k times 180 degrees, where k is an element of integers. Therefore, theta is 45 degrees plus k times 180 degrees, where k is an element of integers. We can stop it there. Now, how many marks? Maybe using the identity there, good. And 2 marks for the answer. Maybe that's how those marks are scored. Okay, right, so let's get to B. B has 1. We need to prove this identity. So now we've got complicated angles this side. So this means that would be the complicated side. So now there's something I'd like to show you guys. We have BODMAS, factorize, identities. Okay, now BODMAS, we can look at it in terms of applications. This means reduction formulae or core functions. Okay, and then the AS part could mean special angles. Okay, SAs. Then of course BODMAS directly looked at its brackets, ordinals or exponents, division, multiplication, addition and subtraction. Now with factorizations, we've got the basic type from grade 8, highest common factor, and we come back to the dots, which is your grade 10 mainly, and then we can do polynomials, which is from the remainder theorem or log division or the bracket methods, whatever that is. And then of course identities. Now guys, this is very important to master, to simplify algebraic expressions. Even for identities, I can include the word law, because it can be any law that applies algebraically or in a particular section. Now let's do it. So the left hand side is equal to sine of 2 theta plus cos of 2 theta plus 1 divided by cos of 2 theta. Now what can we do here? We don't have any like terms. We can't multiply. We can't do anything. So we can come here and say, well, we can start with identities, because that's an identity. So this is 2 sine theta cos theta plus, but now we want to get rid of 1 because there's no constant here. So this is going to be 2 cos squared theta minus 1 plus 1. All divided by, this one we can see the sine and cos. So we can break it up into this one. Okay, good. So we go on. So let's sort it out. So this is 2 sine theta cos theta plus 2 cos squared theta, because the ones will essentially deal with each other nicely there. So we've got cos squared theta minus sine squared theta. Okay, so we handled like terms because these are literally like terms. Okay, great. So what can we do next? Well, we don't have any more like terms per se, but we can actually get to factorizations. But on the numerator, we have the highest common factor, which is 2 cos theta into sine theta plus cos theta divided by, in the denominator we've got the difference of two squares, so this is cos theta minus sine theta into cos theta plus sine theta. Okay, great stuff. So we look at the dm section, we see that this is the same thing as that, so those ones go away. They leave us 2 cos theta divided by cos theta minus sine theta, that is equal to the right hand side. Nice and easy. So how many marks is this? 4 marks. So obviously guys, for using our identities we get our marks straight up, so those are the 3 marks. Nice and easy. But technically this is the same thing. I mean, that identity and this one are more or less the same, so but we are expanding it differently. We can get 3 marks there and say both factorizations are key, and that's how we score those 4 marks most likely. Okay, all right, okay. So now what do we have? We are told to write down, so meaning we need to sort it out. The values of all the values of theta, again key is all the values of theta in this interval for which the identity is undefined. Okay, all right, okay. So what are we going to do? Now we know that this happens when the identity is either 0 here or it's 0 there. Okay, good, it doesn't really matter. So this can happen when cos 2 theta is equal to 0, because that would be undefined. So this implies 2 theta is basically plus or minus arc cos of 0 plus k times 360 degrees, where k is an element of integers. This implies that 2 theta is, that one is plus or minus 90 degrees plus k times 360 degrees, where k is an element of integers. Now this implies that theta is going to be 90 by 2 is plus or minus 45 degrees plus k times 180 degrees, where k is an element of integers. Now let's have a look. So we've got 2 solutions here, plus or minus. So technically this means theta is going to be equal to the set of, now let's look at this. This is going to be 45, because this is 0 to 180, so we can't look at the negative one, 45 degrees. This is when k is 0, but when k is 1, this is outside the domain. But let's look at the negative 45 when k is 1. 180 minus 45 is 135 degrees. And that's it. So those should be the 2 solutions. Great stuff. So we get those 2. So here what we write, we can just say, what is this one? This is number 2. So we can just say theta is equal to 45 degrees and 135 degrees. Okay, this is nice and easy. Okay, so that comes out nicely. But now let's say one chose to approach this differently and say, okay, we took the other one and say cos theta minus sine theta should be 0. Will we get the same answers? Let's see, this is cos theta equals sine theta. This means if we divide by cos theta, 1 is equal to sine theta over cos theta. Therefore, we know that tan theta Let me just respond to this message quickly. Okay guys, so let's have a look. This is equal to 1. This means theta is arc10 of 1 plus k 180 degrees, where k is that one. So this means theta is 45 degrees plus k times 180 degrees, where k is an element of integers. So what do we say here? We can say therefore theta is the set of 45. But now this is when k is 0. But when k is 1, this is outside. When k is minus 1, this is minus 135. So this is outside. We get minus 135 instead. But now, you see, we only get one solution. But now what do? We look back and be like, okay, remember certain approaches are not perfect. So we're going to say, okay, fine, if this is 45, but we saw that in the identity we've got double angles. So technically it means we can explore multiples of 45. Multiples of 45 to consider is 90, 45 by 2. Do we have something like that? 90 by 2, this is 180. So that is valid because now cos of 180 is minus 1, so that one works. Now when you say 90 here, it's going to be 0, but sine of 90 is 1. So that becomes valid. So 90 doesn't come in. Let's say times 3, 45 by 3, it's 135. Ne? And 135 by 2 is 270. Cos of 270 is 0, so this is definitely undefined. Here, 135 is minus 1 over root 2. Sine of 135 is 1 over root 2. So basically, let's see what is going on here now. What's going on? Can it work there? It does work for the first one. It does work, it becomes undefined. But here, this one, doesn't get me 0 though, because this is slightly different now. But this would be negative, it's not positive, and this is not positive again, so oops. Is a bit of a situation, is it not? Yeah, this one doesn't really work, but I guess, guys, it depends on the solution, but I would say multiples of 45 here should be explored, which means 135 is the next one, 90 is out, and that should be the end, because within this interval here, these are the only two solutions. But yeah, this one is a bit tricky for the identity on the right hand side, because it's not giving us what we want, but we're getting there, isn't it? We are getting there. So this is how those solutions are scored. Again, it depends on the approach, so be careful. If you chose this one, you need to explore multiples of 45. Because we saw that we had a double angle there. So this is one thing that you would not be warned about. So you need to be in a position to look at and sort it out. So those are the two solutions. At least this approach covers it nicely. Okay, it covers it nicely. So, yeah, that should be the 2 marks. And that ends the 9 marks here. This is not so bad. Not so bad at all. Okay, let's get to question 5. Now question 5 says, prove the theorem that states that the opposite angles of a cyclic quadrilateral are supplementary. Again, guys, this is in the textbook. Okay, Now we're proving that C plus E is 180, so all we do, we join AD and AF. And of course, whatever we joined, we break it up. This is going to be 1, 2. Nice. So, what do we say? I'll say the construction here, join AD and AF. Then we get to the proof. We can just say O1 is equal to 2 times angle C. Now what is the reason here? Angle at center equal to 2 times angle at circumference. Right, we know that also O2 is going to be 2 times angle E. Same reason, angle at center equals 2 times angle at circumference. Right, we can say, but O1 plus O2 should give us 360 degrees. This is the revolution. Okay, this implies now 2 times angle C plus 2 times angle E should be 360 degrees. We factorize as we know how. Therefore, we divide by 2C plus E is 180 degrees. That is the proof done. Not wasting any time in there. So we've got B. You can just say C proof. This is in the textbooks, guys. You don't need a second invitation for that. So B, we are given that 2 circles intersected C and E. Okay. And G is a point on chord HF in the bigger circle. Okay, we see that G is a tangent to the smaller circle at E. Now if it is a tangent, we might want to highlight it. Okay, that should be a tangent, maybe a bit better. Okay, it's not a straight line, it proves it. Okay, great. Now if this is a tangent, we know that the angle between the tangent and the chord for the smaller circle should be equal to the angle subtended by that chord at circumference. Now that is what we have. So this means E2 is 73 degrees. Right. And we are told FHC is 75. D is a point on the smaller circle with CDE equaling 73 degrees. Now we need to give reasons where required in determining the size of angle E1. Okay, so what do we see? So guys, if we look at this, we see that this is a cyclic quad because all vertices of that quadrilateral are at circumference. And so we can use that property because this angle overlaps with that. And yet this whole angle E1 plus 2 plus 75 is supplementary because of the proof we just did above. So we can start off by saying, well, angle E2 should be equal to angle D equal to 73 degrees. Why? This is the 10 chord theorem. Okay. Now, what are we going to do? We can say here then, we understand that angle H plus angle E1 plus angle E2 should be equal to 180 degrees. These are the opposite angles of a cyclic quad. We name it HCEF, okay? Because no one stated it nicely, so we need to prove that it is indeed so. Now this implies H is 75 degrees plus E1 is what we want, plus E2, we said it's 73 degrees, equals 180. Therefore, angle E1 will be 180 minus the sum of 75 and 73. Whew. Feeling tired, folks, already. 32 degrees, ne? Great. Okay. So that's cool. Now, how many marks was this? 5, really? I win. Don't be playing here. Okay, maybe this one is 2 marks, I would believe. This statement is a mark. How? 5 marks, guys? Really? And then this one, 4 marks, and maybe we can say substitutions, okay? Yo. They're just throwing and showering students with marks there. Okay, see, we have, in the diagram below, C is a point on the chord BE, okay, and F is a point on the chord DE, such that EF is equal to FD, okay? Now, A is the center. Great stuff. If A is the center, we know that line from center to midpoint of chord is perpendicular to chord, so that angle should be 90 degrees. Now DAB is 86. Great, not a problem, and we know these are ready. So if these are ready, then this angle here is equal to that angle. Nice. Now question says determine the size of D2. Okay, this one. So this is the one, D2. Okay, but now we know that this angle should be equal to that in this triangle. So it means we're looking at that particular triangle. It's an isosceles triangle. So C, we know that in triangle ABD, what do we see? We know that technically angle D2 should be equal to angle B2. These are angles opposite equal sides with radii AB equal to AD. Okay, then we know that angle D2 plus angle B2 plus angle DAB, we should get 180. Sum of 3 angles of a triangle. Now, this is the same as just 2 times angle D2 plus 86 degrees equals 180 degrees. This implies, maybe we might even move quick and say, therefore, this angle D2 is going to be 180 degrees minus 86 degrees divided by 2. Okay, let's pull it out of the hand. 180 minus 86 divided by 2 is 47. We are getting 47 degrees. Nice and easy. Okay, so easy stuff. Of course, guys, this could be a catch by the examiner because you may take this lightly and end up suffering. Okay, so you don't want to suffer. you want to take it nicely and move on with your life, without a problem. Okay, now let's get to the next question. 2 says we need the size of DEB. So this is this angle right here. Now that angle is 2 times this angle, or this angle is 2 times that angle. Angle at center equals 2 times the angle at circumference for the same chord or arc DB. That's easy. So we know that angle DEB is going to, in fact, let's do it this way. We know that 2 times angle DEB, we should get DAB. Angle at center equals 2 times angle at circumference. Now this implies that 2 times angle DEB is going to be 86 degrees. Therefore DEB is 86 divided by 2, that is 43 degrees. Okay, so obviously we're just scoring the mark for the answer. We're going on. This was easy though, but I don't know why. Okay, let's see. This one is what? 4 marks. Okay. We need to prove that DACB. Okay guys, so there is our cyclic quad. So now how will we prove this? If we already proved that this angle is a particular size, we can actually use that to prove that it is equal to that other angle. That would be the exterior angle of a cyclic quad. So if we prove C1 is equal to D2, then we have proven this thing. But now we have a bit of a situation also. So if we look at that triangle, this can help us to find C1, because we'll have the exterior angle, we just found that one, and therefore we can work out that angle. And if that angle turns out to be equal to that, we can use the converse of the exterior angle of a cyclic quad. Okay, this is going to need a bit of work. So we can simply say in triangle, say CEF. What do we see there? We can see that this angle CFD is 90 degrees. Why? This is the line from center to midpoint of chord, bisects the chord. Okay, that's number 1. We can say also, we know that angle C1 plus angle E in that triangle should be equal to angle CFD. This is the exterior angle of a triangle. We're still talking about the same triangle, which implies that angle C1 plus angle DEB, which was 43 degrees, is equal to 90 degrees. Therefore angle C1 is going to be 90 minus 43, we get 47. Now can you see that this is equal to that angle there, D2? So we can say therefore angle C1 is nothing but equal to angle D2. Okay, why? Each is 47 degrees. That's why. Therefore, we can make a conclusion now that DACB is a cyclic quad. Now this is the converse of exterior angle of a cyclic quad. Nice. So we can see that if we proved that the exterior is equal to the opposite interior, it then proves conversely that this is a cyclic quad. So this is the proof backward. Okay guys, so easy 4 marks there. So that is important. That is key. That is key. And the last statement. So I don't know how these 4 marks are structured, guys. You look for it in the formal marking guidelines. So this would be some easy 16 marks if we did not commit any mistakes along our workings. Okay, now we are hitting statistics. Okay, let's hit it hard. Question 6. Refer to the table below. Okay, this is a bivariate data, so we know calculator work is on point here. So let's go mode, choose option 3, then option 2, then we put in 10, 16, 11, 12, 32, 24, 21, 19. So we've got 1, 2, 3, 4, 5, 6, 7, 8 entries. So I've got 8 entries in the calculator, so it means we are good. So 10 went with 17, 35, 20, 23, 83, 59, 50, 44. So we've got 8 entries. So we hit our AC button and we are ready to answer some questions. So A, we need to calculate the correlation coefficient. Okay, that's easy. So 1, we go to our calculator there, shift, button number 1, then we press 5, regression, and then option 3, we hit the answer, we get 1. R is 1, so this is a correlation coefficient, so no unit for it. So 2, what can you infer from your answer? Of course, this is a perfect. It's a perfect positive correlation between the two variables x and y. Okay, always answer fully, guys. Do not answer things like you are writing a telegraph here, but hey, who cares? Nobody does. Okay, the most important is to say it's a perfect positive correlation. That gives us 1 mark. 3. So use your calculator to determine the equation of the line of the best fit, okay, in the standard format. Okay, so we know that we want A, we want B, and then we can write it. So let's go to our calculator and find out those things. Shift, stat, regression, then A, we get minus 13. Then we repeat the process. One thing that is annoying about this is that you have to keep doing this. Okay, get plus 3. So this is going to be minus 13 plus 3x. Alright, okay, alright. Maybe we can take away the cap because we are already given a rule that we need to satisfy. So how many marks? 2 marks. Means for those 2, 1 mark, and for the thing, nice and easy. 4 says give a positive value for x where it might not be wise a decision to predict a value of y using the line of the best fit, and explain your answer. Okay, that means we just need to choose an x value that is outside the domain, right? Now if we look here, we'll check here. This is the biggest, this is the smallest, so anything outside 32 and 10 can work. So I can just choose any value and say fine, I can choose 40, let's just say 52. The reason is this is outside, oops, this value of x is outside the domain, okay? Given, okay, and so would constitute an extrapolation, right, which is an inherently inherently inaccurate prediction. Okay, so basically we're just trying to suggest that if we ever predicted outside the domain, we are inherently being inaccurate. Okay, basically that is the story. So obviously we get a mark for that, and we get a mark for the explanation, most likely 1 mark. Okay, 1 mark for everything, not a big deal. So we move on to B, the ogive. So let's look at B. Now B says below is a cumulative frequency curve that represents the amount of people spent looking at a screen each day. Okay, obviously it's grounded here. This would be the lower limit of the first class, so this should be the first class all the way up until 30. Then the second class is that one up until that. Third class is that one, and fourth class is this one, and the final and last class is this one. Okay, so that is the stories there that we are getting, and we know that with the ogive we actually plot the upper limits of each class and the cumulative number corresponding to that. Now we know that, okay, all right, we understand, and we always do, that the last plot gives us the total number of participants that are in this thing. Nice and easy, so we can leave it at that. Again, we may want to look for the model class. The model class, we look at the steepest gradient. This looks a bit gentle. I think the gradient is steeper here. We draw a tangent line there and a tangent line there. Yeah, that one is steeper, and then they become gentle. So that is the steepest. So this would mean this would be the modal class if someone asked a question. So always be able to interpret the ogive. It's fairly easy. So let's start answering. It says how many people spent between 30 and 60 minutes on the screen during each day. 30, we go up to the ogive. Okay, Okay, and then we take it across, that is 20. So that is 20. For 60, we go up to the ogive as well, and then take it across. So we've got 60 people. So now the difference here should give us the number. So 1, we can say number of people is going to be 60 minus 20, which is going to be equal to 40 people. Okay, nice and easy. Great, so that's not a difficult question to do. All right, okay. Now, what percentage of people spends more than 120? More than 120 is all these ones going up there. So we go to 120 on our ogive. There it is. So we go across to read how many people are at exactly that. So we can see this is the one. So the difference between those two, because more than 120 is everyone else. So we need those numbers. So we need to find that number. And essentially, question says percentage. So we are good. So we can say 2, the percentage of people is going to be the total 140 minus 130 divided by the total here, which is 140 multiplied by 100%. All right, okay, we do it. What is this? Let's see. 140 minus 130 is 10 divided by 140, that is the 1. Then we multiply that thing with 100. What we get there is 7,1% to 1 decimal place. Remember, everything is to 1 decimal place here, unless otherwise stated. Okay, so how many marks is this thing? 2 marks. Okay, I think that calculation is key and the answer. Okay, easy, 8 marks on the stats right there. Not a problem. So that ends section A. Okay, let's hit section B, running and screaming and kicking and crying. Question 7. So what do we have here? 7A says the box and whisker plot below shows a summary of the results of students who wrote the same maths test. In class A, there are 28 students. Totals are important. In class B, there are 25 students. Okay, including the student represented by point P, so technically that would be 26. Okay, great. Now we can see that, okay, all right, this is the story that we see there. You can see the median is 40, Q3 is 45, Q1 is 35, minimum is 30, maximum 60, this one minimum 45, Q1 is 60, it coincides with the maximum of class A. The median is in between 75 and 80, maybe around 78, 77. And then we've got 85 over there, maximum. Okay, cool. We understand what is going on in there. First question says, a data value is an outlier if it is less than Q1 minus 1,5 of the IQR, or greater than Q3 plus 1,5 of the IQR. Now we need to show that P is an outlier. Okay, this is in relation to class B. Okay, so obviously if we look at position of point P, we can appreciate this is below 30. We can say, well, we understand that P is less than 30. That is given. Okay? Now, we can say then, we understand that Q1, this is on the side of Q1 plus 1,5 of the IQR. Of IQR is equal to Q1 there is 60 plus 1,5. IQR is going to be Q3, that's 80, minus Q1, which is 60. So this is for class B. This is going to be equal to 60 plus, okay, maske siyibambe lapho, 1,5 into 80 minus 60 is 30. Okay, that was not a plus. I'm making a mistake, so this should be a minus. See, easy questions are trying to make me trip and fall. So this is 60 minus 30, which is 30. So that means 30 is the lower limit for us to say something is within this study group. Anything outside is an outlier, and we can see that P. So we can say therefore P is an outlier since P is less than 30. Nice and easy. Okay, not quite a technical question here. 3 marks. I suppose finding that value was key. Getting the lower limit is good. I think we can say the rest of the substitutions, whatever, because this was already clear and evident. So look at the memo again for how this is marked. It looks strange. For 3 marks, no man, that is not right. Okay, the teacher of class B says that their data is skewed. State whether data is skewed to the left or to the right and explain your answer. Okay, class B, as we can see, there's more data values to the left of the median. So definitely this is something like this. If we're to draw a normal distribution curve, it would be something like so. Right, so this would be the median, Q2, but then the mean would lie somewhere there. Okay, so this is somewhat what we would see on a distribution curve. So that translates to this. So what are we saying? We're saying it is skewed to the left because there's more data points to the left of Q2 than it is to the right. So it is skewed to the left. Now we need to provide an explanation here. We would know that the mean I don't know, guys, my writing is just not good. The mean lies to the left of Q2, or of the median. Let's just put it that way, of median. Okay, in brackets we can say X bar is less than Q2. Nice and easy. So of course skewed to the left, it's a mark, and explaining this, so it means you need to understand the distribution curve. Okay, especially for normally distributed data and the skewed data. Not a big deal otherwise. 3 says one of the teachers states that 13 students in the grade got between 45 and 60. 45 and 60 for the test. Could they be correct? Explain your answer. Okay. All right, now we need to calculate. So what do we see here, folks? What we see is that 45 is here and 60 is here. Okay. So what we notice is that this is basically 25% of class B. Okay, that is 25% of class B. But then this is, again, if we look at it from here to there, this is again 25% of A. Okay, because remember, this is divided into quarters, which is 25%. So from Q3 to maximum, it's 25%. So from minimum to first Q there, or Q1, that was also 25%. So this is what we need to find out. What is 25% of 8? Will give us the number of students. So we can say, well, number of students is going to be 25% of A plus 25% of B. So what is that? So this is going to be 25 over 100 multiplied by, what was the class A? 28 students, plus 25 over 100 of class B. We saw that they are actually 26 when we include the outline. Let's see how much is that. So 25 over 100. Let's go to computing. This is already giving me flames. 25 over 100 times 28. So that is giving us 7. Plus, let's see, what is that one? 25 over 100 of 26 times 26. That is giving us 6,5, but we can't have 6,5, so the whole number. So this is 6. Okay, we can't have a comma when it comes to students, and we can't round down or round up. This is the number of people. So that is 6. And that is how many students? 13 students. So this is going to be equal to 13. Yes, we can say yes. The teacher, is correct. Okay. So the explanation is a calculation. Remember, an explanation doesn't have to be words. Okay. Okay, teach is reg, die teacher there. Yeah, the teacher is reg, man. He knows these things. He knows his things or her things. Now let's see. How many marks are we scoring here? You can't tell me this one. So this is just the stuff I buffets. This is the one. That is the one. Okay, that is the one. That is the one. Okay. All right. Okay, we'll leave it at that. So we go to B. Baba. Can we answer B here? No, I must B. B, we have our grouped data. The table below shows the height of trees in a forest. Okay, that is the story. And so this one is not given. It means we need to find out when we're not given the total. So it says if the approximate mean for the height of the trees is 5 meters, calculate the value of B. So we need to find the total there. The total in here is going to be all those numbers plus B there. So we're going to have 165 plus 290 plus 185 plus 75. So this is 715 plus P. That is the total. We understand that this is the one. Now we needed midpoints. So if you want midpoints here, the midpointer so is going to be this one. 1 plus 0 divided by 2 is 1. This one is 6 divided by 2 is 3. This one is 10 divided by 2, that's 5. This one is 14 divided by 2, that's 7. This is 18 divided by 2, that's 9. And we can see 1, 3, 5, 7, 9. It increases by 2 there, so that should be correct. That should be correct. So that's what we do there. We want the midpoints because we know that the mean is going to be the midpoint of each multiplied by the frequency. So it's going to be 1 times P plus 3. Okay, maybe let's do it this way. Let's do it this way. This is 1 into P. I don't like that thing. Plus, this is going to be 3 into 165. Okay. Plus 5 into 290. Plus 7 into 185. Plus 9 into 75. All of that divided by the total, which is 715 plus P. Okay, very nice equation there. So this is the mean, so we just put it there. This is 5 over 1. Now what do? We cross multiply and do our business of the day. So this implies that we've got 715 times 5. 715 times 5. So this is 35. 75 plus 5p is equal to, now we can sort all these other numbers there. So this is 3 into 165 plus 5 into 290 plus 7 into 185 plus 9 into 75. Okay, just make sure everything, guys, is done properly. So this is nothing but P plus 3915. Okay, great. So what do? We move P to the other side. This implies that 4P is equal to, so we take this one and subtract 3575. We get 340. Therefore P is 340 divided by 4, it's 85. Okay, so P is 85 degrees. Nice and easy. Not a difficult question, to be honest. Now we're getting a mark for the answer. We're getting a mark for the substitution and everything else there. So easy, 3 marks. Not a difficult question there. So yeah, I'm tired, folks. I'm yawning like a baby, you know, like a baba. You see now this numbering of IEB. You see this numbering of IEB. But even with the DBE, man, I still make this thing, man. I still make this thing. Hey, I don't understand. Why are my numbers flying now? Hey, kimuhlo. Shokimuhlo. Lo Agirata Line. Hey, asingaculi. Ithini nalento? Imfihlelo yobomi leyo. Ngambe sibuza izinto esingazazi nathi. Ithi ke ngoku 200 new trees of a height 10 centimeters were planted. Nice. Once these have been recorded, it is given that, holy cross. Now that is the sigma notase. This is the sigma notase, this one. Now what are we going to do with this one? It's already telling us that the number, when we add them together, we get that one. Now once we get that one, this is also telling us that the top number is this one there for our sigma. So it's 915 plus b. But now what is b? We got b to be 85, so this means it's going to be plus 85 over there. And of course we're starting at 1, so this is nothing but what we call the variance. Yabona nanisazi ke bafethu isingesi ingxaki xa ningasazi nizoba nengxaki. So you need to know what this thing is. Once we square the difference of the mean from each individual x value, this is called the variance. Now when we take the square root of a variance, we get the standard deviation. You see, it says determine the new approximate standard deviation. You are talking our language. So the total of the variance is this one, because the sigma, this is now trying to tap into your knowledge of sequences and series. Do you understand that thing? Or did you just pass it by luck? If we passing a luck, so this is trying to suggest that what is the number of terms here? The number of terms is going to be 915 plus 85 minus 1 plus 1. So this is the one. So plus 915. So this gives us 1,000. It's giving us tau. Huh? Tau. Ke chelete ya mavuso. Alwa itse lena here mavuso ke eng. Le ske la mpotsa ntho. Hana le reng. Le ske la mputshisha dintho. Hana ba re keng. Le ske la mputshisha dilo. Tje sing botse. Yeah, let's get mpotšisha dilo tse di seng botse man. Batla dilo tse di botsananyana wa bona. Yeah, ska mpotsa dilo tse. Ska mpotšisha dilo tsena man. Tlawetha ka bekeng. Tlawetha ka bekeng. Ha ke batla ho wetha motho jwang. All right. Determine the new approximate standard deviation. We know that standard deviation, guys, this thing is the square root of the variance, you see. Yeah, it's the square root of the variance. It's actually not the variance, but if you take the variance, it's the mean. Guys, it's the square root of the variance technically. Yeah, man. Divided by the total. So we just do that and take the square root of that whole thing. This whole thing gives us the variance. So standard deviation is the square root of the variance. The variance itself is this thing. Is all those things squared, totaling to this one over the actual total. That gives us the variance. Yeah, man. This implies that our standard deviation is like this. Now the total is 6520 divided by 1000. You see, but I do think my 1000 is not telling the truth in fact. It's not telling the truth in fact. Why says no 1000 payana? Singambonango to velepi. We need to show this one is 915 plus 85, okay? Minus 1 plus 1. We have to show that thing. And therefore, our standard deviation is going to be what we get over there. So this is the square root of 6520 divided by 1 decent. So this one is going to be 2, sigiza. Remember, we were told by how much must we round this one off? No. So if we're not told, we are going to tell ourselves, okay? We have to tell ourselves because we were told to 1 decimal place. So this does not have a unit. But maybe we can say 3s because the standard deviation is at 3. So that now this one becomes a bit of a problem, you see. Because if it is a problem like this, you start to ask yourself, do I write 3s? Can I get 2.5? 2.6 3s? It means these ones are the small ones. Now, how do you define a 3? I mean, it's just a number, you see. So technically, approximately 3 3s. 3 3s. Standard deviation is something that we calculate, man. So it must not really be the truth. In general, this is just 2 3s. This differs by 2 3s because this is an exact number. We can't have a comma. There's no 3 comma some change here or 3 comma some branch. Yeah, 2 marks. So folks, the key thing was the substitutions and the answer. Substitutions and the answer. Then we take our 12 marks. So hey guys, let's spend the 2 hours la. It's slow most. We are slow. We need to move, guys. I'm hungry also, and time is not on our side either. Okay, that was question 6. Yo. Hey, question 7. Yewena. Sasiyakechi masiyakabatu lamos. So we are moving fast. We are galloping. Siyakabatu. Siyapara. The bird is sparring. In the diagram below, the semicircle, this one with the center A. So if this is the center, the contour, we know that this one is equal to this one, is equal to that one, equal to that one, equal to that one. Because these are ready. If these are ready, this is already suggesting that this dude and that dude must be 2 equal angles. These are angles opposite equal sides in that triangle there. So what are we going to say now? Well, we've got lots to say, but I'm trying to think, am I going to say all the right things? Now, it says with the diameter FAE. Okay, we can see that diameter there, not a problem. And then BC are on the same horizontal plane. So we told B and C are in the same horizontal plane. That should also include A. Great. Now, what are we told? We told yes, CB is 9 meters. So this is indicated. This is indicated. And CAB is 110 degrees. That's also indicated. Now 8 is a vertical tower. So if it is a vertical tower, this must be perpendicular to this one, perpendicular to that one, because these are on the horizontal plane. Nice and easy. Now we are told, okay, plane end is 2 meters high. Okay, so that's already indicated. Okay, there's so much here. Now we are told to calculate the length of dB and to round off. Now we are being told to 4 decimal places. Okay, all right. Okay, so we start A. We want dB. This is the hypotenuse side. Okay, now this means, we have to start in that triangle, right? Because we've got a length given to us, and we can look for this side, which is the common side. And these two sides are equal anyway, so the good thing is that we can just use the sine rule here, because it's an isosceles triangle, so we can get these angles. It won't be a problem. So let's first find those angles, because we just need one, maybe angle C there. So we can say here, first in triangle ABC, what do we see there? We understand that basically angle ACB, angle ACB is equal to angle ABC. These are angles opposite equal sides with already AC equals AB. Okay, we know that also. We understand that angle ACB plus ABC plus that angle, that's CAB, we should get 180 degrees. This is the sum of 3 angles of a triangle. Okay, so this implies that 2 times, as I said, these are equal, 2 times ACB plus 110 equals 180 degrees. Therefore ACB is going to be 180 degrees minus 110 degrees divided by 2. Let's get it. It's 180 minus 110 divided by 2. So we get 35 degrees. Okay. Now we can say then, how many marks? Yeah. I can see that is quite a lot. So what can we say? We can say then we know that we want AB over sine of the angle opposite that, which is sine of ACB, should be equal to, again we know that those sides are equal as well, so we stated it here. Hey, this question is crazy. No, I don't need that one. I can use this one, that this is CB over sine CAB. That is the sine rule in that triangle. So AB is the one we want, times sine of ACB, we just found out is 35 degrees, is equal to, this one is 9, divided by the sine of 110 degrees. So we just cross multiply there. Therefore AB is going to be 9 times sine of 35 degrees divided by sine of 110 degrees. All right, so this is quite an essay. You can see now le wena wa iponela hore di ntsha tsotsi ka mona, di ntsha tsotsi. Ha se papadi. Ha re bapale diketo. Ke ntho tse bonolo fela tsena, se ke wa tshoha. So this is 5, comma. Now we can protect our answer and say 4, 9, 3, 4, 8, 5, 6, 4, 9. Let's leave it like that. Remember, this is meters. But that was not the question. The question was dB. Now we move into that yellow triangle because that's where dB is. It's a right-angled triangle. So we can say in triangle ABD. What do we say there? We know that dB squared is equal to AD squared plus AB squared. This is from Pythagoras because that's a right-angled triangle. So this implies that dB squared is AD 2 squared plus this one is 5, 4, 9, 3, 4, 8, 5, 6, 4, 9 all squared. Therefore dB is going to be equal to the square root of all of that. So this is 2 squared plus 5, 4, 9, 3, 4, 8, 5, 6, 4, 9 all squared. Ya re panisha bjano. Answer squared plus 4. Then we take the square root of the answer again. Just moving faster, guys. So I'm getting 5, 8, 4, 6, 2. We're told to 4 decimal places. Now this is meters. Okay. So please don't forget we were given these units, these measurements in meters. So it has to be presented as such. Don't find yourself writing units there. You will be dead because you are given straightforward. So you can see this is one of those silly questions where there's too many steps to consider and we go through it nicely without rushing it. How do we score marks here? Obviously finding this angle is key. Then setting up the sine rule and maybe substituting and getting the answer, that is the 3rd mark, and then substituting into Pythagoras and the answer together with the unit. And I'm sure you may get a mark here or anywhere else really. Yeah, anywhere else, but in total we are 6 marks rich. Now we have B. Okay, we've got B. B says we need to find the size of CDB. CDB. Oh. Wow, what is going on there? We know that those two triangles are congruent. How do we know? We know that this side is common. This side is equal to that side. And we were told that this 90 degrees right here. And so that was also 90 degrees over there. So can you see side included angle? So those are congruent, suggesting that this one is equal to that one. So literally this drives us into that big triangle, you see, CBD. Now if we have those sides equal, right, so it means we can just use our cosine rule to find the angle, because that's the angle we're supposed to find. So can you see? Wow, very nice, very nice. How many marks? Just 3 marks. So we don't need to justify the congruency, we just go for it. We're not gonna waste time. So we know that, well, in triangle CBD, the Central Business District, what is happening there? We understand that technically, essentially, if we just want to say things that we must say, we just know that basically CD must be equal to DB. What are we going to say? We'll just say these are the corresponding sides in congruent triangles. We know that corresponding sides of congruent triangles, congruent triangles with triangle ACD congruent to triangle ABD. Okay, maybe let's move this one a bit. In a situation of a side angle side. Okay, someone may also think of the right angle hypotenuse side type of a thing, because it still applies. I think that is the most important, because we can then set up the cosine rule. We know that basically CB squared is going to be equal to CD squared plus DB squared minus 2 CD dB, the cosine of C dB. Okay, now we substitute. This is going to be CB is 9 squared, CD is 5,8462 squared plus DB. So wait, yes, it's the same thing, and then it's 5,8462 squared minus 2 into 5,8462 all squared times the cos of CDB. Okay, I'm moving a bit quicker because space is not on my side, so this is 81. Okay, maybe let's not try to be heroes here. It's going to be very dangerous to do such bad work. So what are we looking for? We're looking for cos of, so this is going to be 9 squared minus 2 into 5,8462 all squared, because those are going to be doubled, all divided by 2 into 5,8462 all squared. Now we can then sort it up and say CDB is going to be arc cos of 9 squared minus 2 into 5,8462 squared divided by 2 into 5, comma 8462 all squared. And let's get the angle. What is this angle there? It is what it is. So shift cos of 9 squared minus 2 into 5, comma 8462 all squared divided by 2 into 5, comma 8462 all squared. So what do we get in there? What are we getting in there? Yo, guys, I don't want to lie. The guy is fried. You see, the guy is super duper fried. So we're doing what? The cosine rule. Okay. Oh my lord, look at that. Look at that. Look at that. So this is supposed to be negative. Yeah, ne, double check guys. Yanyiwa, masekunyiwa. Nazathi nanibone izibhorho mina. Kanti hayi nini izibhorho ngiyaporha nje. Ndiyaporha kulo nyaka. Ndiyaporha kulo nyaka sekunzima. Ndiyaporha kulo nyaka. December kulo nyaka sekunzima. We're doing it to one decimal place, ne? So this is going to be 7, ne? Yeah. So be careful guys of your substitutions. You can run into a corner out of commission. See, sometimes when the calculation is this busy and you're already tired, hey, things can look very ugly for you there. So I don't know guys what is the story there, but I do believe this statement is important, né? And then the substitutions are important and the answer, however complicated this looks. So we're just getting 9 marks. Okay, a bit of a nasty 9 marks, eh? Bit of a nasty one, a bit of a nasty one. Now we're going to some Euclidean geometry. Question 9. Okay. Question 9 says, in the diagram below, CD and DE are tangents. So this is a tangent. That one is also a tangent, like this. So we know that tangents from the same point outside the circle should be equal. Whereas we've got the 10 chord theorem. So of course these ones are equal nicely like this. And they are both equal to that one. From the 10 chord theorem. We can even link them using that. Now A is the center of the circle. So if this is the contour, we are home free. So this is equal to that, equal to that, equal to that. So this is suggesting that we also have this angle there added to the crew. That angle is equal to that one. Angles opposite equal sides. And also C2 and E1 ziyalingana. So it's a bit hectic, Now prove that triangle ABC. So it's this triangle and triangle DEC. So we're looking at those two triangles. We can already see that we have two sets of equal angles there, and therefore the third pair should be nothing but the same thing. So we'll start here and say A in triangle A, B, C, and triangle DEC. What do we know? What do we know? What do we know? What do we know? We know that essentially in ABC, we know that angle B is equal to angle E2. Just going to choose those. This is the 10 chord theorem. Okay, nice, we are done there. What else do we know? We know also that angle C1 in that triangle is equal to angle B in the same triangle. Right. These are angles, opposite equal sides, okay, in triangle ABC with already AB equal to AC. Okay, this is important. We've got a but. We know that angle B, okay, we know that but angle C2 is equal to angle B. 10 chord theorem. Yeah, 10 chord theorem. So what happens to the 10 chord theorem there? So it makes a conclusion that C1 on the other triangle must be equal to C2 on the other triangle. Each equal to angle B. So we can say safely that this implies that angle A1 must be equal to angle D. So these are the remaining angles. Therefore, triangle ABC is similar to triangle DEC. They are equiangular, AAA. Okay, so that is key. That is also key. This is key. This is key. This is key. 5 marks, nice and easy. And then we have to prove this one. So B says AE. Where is AE? AE is here. Okay. This is the foreigners. EC. EC is on this triangle. BC, it's on the other one. DE, it's on the other one. So good. So we know that we need to substitute perhaps AB with AE because those are ready. Nice and easy. So easy 3 marks here. So we know that, okay, all right, okay. We just want AB here from the other one. Over. Now AB is opposite C1. C1 we said is equal to C2, and the side opposite C2 is ED or DE. So we can write here DE is equal to, I want BC also. So this is BC over, BC is opposite A1. A1 is equal to D. D is opposite EC. So these are the proportional sides in similar triangles in A above. So all we do is just cross multiply here. So this implies that AB times EC should be equal to BC times DE. We've got a but. We know that actually AB is equal to AE. These are already. Therefore, we substitute AB for AE times EC should be equal to BC times DE. Okay, nice and sweet. So technically, this statement is key, and that statement is key in the answer, although it's already given, you know. Yeah, the substitution is an action. Okay, guys, so this is nice. Easy 8 marks. No problem, no problem. Now let me just eat something at this point so that we can carry on with question 10. Okay, it's not looking bad and all the others, okay? So let me just chow quickly. I'm hungry now. Okay, folks, let's move on. Just take off this cable. I also charged my tablet a bit. So, guys, these questions are just too many. Question 10 says, in the diagram below, E lies on AB. We see that. F on AC, with EF parallel to BC. Great. G lies on FB, and H on FC, yes, with triangle FBC, in triangle FBC with GH parallel to BC. We see that, okay, not a problem. We're told that AE over EB is 4 over 5, so this is 4A, 5A. Always choose some letter to avoid saying those are the lengths. No, that's a ratio. Then we've got FG. So we've got FG over FB. We can say this is 5 over 8. So this could be 8B. This is 5B. Okay, great. So again, choose some multiple to avoid suggesting that those are the actual lengths. That is just a ratio. All right, guys. Okay. All right. Now we need to calculate the value of AF over AC. Okay, so this is easy. So we have A with number 1. So we know that in triangle ABC, what do we see there? We know that actually AF over AC should be equal to AE over AB. This is the prop theorem with EF parallel to BC. Okay, all right, because remember, it is only applicable when we have such a setup. If you miss this, you lose those marks. Ne? Remember that. So this implies that AF over AC should be AE is 4A divided by 5A. No? Line. This is going to be 9A. And of course, these ones will do the thing. Therefore, AF over AC is going to be 4 over 9. Nice and easy. Pretty easy stuff in there. Of course, you will have this diagram on your answer sheet. You annotate it. Somebody will see where the A is, okay? This is just how we handle this business here. Substitutions, answer. Nice, 2 marks. Now we have a bit of a steep one. We need HC over AF. HC over AF. This one over that one. Such a situation. So what are we going to do? Now we've got 4 marks here. So this is already suggesting we are going to do a little bit of sweating. So what are we going to do? What are we gonna do? We're gonna do something like this. You see, we've got this triangle there. We've got this triangle here. So we've got that triangle. We can use that triangle to something, because I mean, if this is 8B, this is 5B, this should be basically 3B. This little portion here is 3B. Logically. So we can use this one to get this HC over that. Ne? Yeah, that we can do. And then what are we going to do next? We then could use the big one, you know? We could then use the big one to our big advantage there. But I'm trying to see how is that HC going to be over AF. But what is nice is that technically this would be the common side. Because if we use it here and then we use it there, it's common. So we will be able to get something, you see. I believe so. Okay. It's not a problem. Let us start. We know that well in triangle BCF. What we want to say is this one is essentially, we know that HC over, we can just say CF, is going to be equal to BG over G over BF. Now I'm trying to think. Is that smart? I want that FH. I want that FH. So let me do it the other way around. Let's do this. HC over HF. I want that HF to come out. It's going to be BG over GF. Okay. This is the prop theorem with GH parallel to BC in this triangle we're talking about. Now this implies that, well, what am I looking for, guys? I'm trying to find this dude. Because if I can find this dude, I'll try to use simultaneous equations and see if I'm gonna get Verify indeed, but now we just need to substitute HC over HF. It's going to be BG. Now this is going to be 8B minus 5B. We just show that that is a calculation divided by GF. It was given 5B. So this is not so bad. Ne? And then we cross multiply here and we do our things. So we can say here, therefore HF is going to be HC times 5B divided by 3B. Okay, so literally these ones will do the thing because those are just the B's, which is going to be 5HC over 3. That's number 1. Let's look at number 2. What can we do? It looks like we're running out of space now. So quickly. Now we want to say also in triangle ABC. We have a story. We know that essentially now I can see where my problem is going to come. So I can't use the big one. I can't, because this part FH common as it looks, but it's not common in the big one. Yawena udlala kan so udlala ka so udlala kan sekuboni yeah man, it's not cool. This one is not cool. Okay. This is making me think a bit, but we can still use the big one, and find the whole of FC. We can find the whole of FC, so FC minus HC will give us that. I'm trying to think, how is this going to help me? Essentially, how does this thing help me, man? Help me, Kalok. Help me. Stuck with 4 marks. This 4 marks is trying to do stuff to me. Okay, guys, let's see. In that triangle, what do we want? We want AF. Actually, we want to solve AF. I don't know if it's going to work. AF over FC is going to be AE over EB. Ne? Prop theorem with AEF, parallel to BC. Nice. So, what is the stories that we are telling? We are telling this story there. We will say this implies we want AF. But now I have a bit of a problem, but we will see what we're going to do. So FC is basically FH plus HC. So we can write FH plus HC. Now I'm trying to be crafty now. Okay, maybe let's... yeah, but it's good. This is substitution. So AE is 4A. I don't know what I'm doing here now. 4A divided by 5A. So these dudes will do the thing, implying that we are doing this. We are doing this now. We have AF over FH. We can even call a FH. Let's just write it strangely, the way we have written it here, HF. So this is HF plus HC is equal to 4 over 5. All right, we cross multiply that thing. This implies that OAF is equal to 4 into HF plus HC over over 5. Nice. So this also implies that AF is going to be 4 into what is HF is 5 HC over 3 plus HC. When e ka re ho tlolla diphadi jwale e ka re ke a e bona jwale mo yang twena e batla ho re etsetsa mathata. But this is not a bad idea, because if I can represent HF in terms of this HC, in fact this will just sort my problems nicely. HF is equal to, now this is going to be times that is 3, that is 8 over 3, so this is 4 into 8 HC over 3 divided by 5. All right, okay, all right. So we continue, guys. My approach is crazy, but hey, it works. 8 by 4, this is 32. Is it? Let me see. 4 times 8, yeah. This is 32 over 3. HC divided by 5 over 1. Just want this to be nicely done, guys. So this is becoming silly, eh? Just 4 marks. Yeah, I chose a crazy approach, guys. What can I do? So this is 32 over 3 HC times 5 times 1 over 5. So AF is equal to, we multiply here, this is 32 over 15 HC. Now what can we do? Well, what we can do, this is an equation now. This can actually solve the pain. I mean, I've already used what I wanted to use, so I can actually divide by AF on both sides. Right? Yeah, let's divide by AF, so we get 1 equals actually what I want to get rid of is this one, so we can just do this. We can be smart and say we want to divide on both sides by 32 over 15 AF. What will we get? When we divide by this, we get 15 over 2 is equal to HC over AF. Can you see? Very interesting stuff. Yay! But why does it look like it's not right, man? It looks like it's not right. It's not right. Where is 32? Oh, goodness. This is 32, not 2. Yeah, now that is correct. Yeah, well. This is what we get. Hey, o bone dintho jwale, o bone dintho. Ke o jwetsa. Yeah, if you divide by this one flips on this side, so it becomes 15 over 2. So we can just write nicely, therefore HC over AF should be equal to 15 over 32. Yeah. Okay, that was a bit of a nasty approach. Simultaneous equations. Remember these questions, they like to do that. Okay. All right, so here we just substituted like we have tried to do our thing, and then it worked out nicely. So we just played a mathematical trick. So I don't know where those 4 marks are, guys, but if I can tell you a secret that I can tell you is this one. This is a mark. So this was a calculation. That's also a mark. Now doing the prop theorem here is not really that great, but I suppose the substitution here is the one that is important. That's the 3rd mark and the final answer. So usually the questions on the prop theorem like to be a bit nasty. You just have to handle it. Okay. So B, in the diagram below, A is the center of the circle, so this is the center. And we know these already, so this one is equal to that. Great. Now B, C, D, and E lie on the circumference, meaning they are concyclic. Okay, nice. And then we have DAB is the diameter. If that's the case, this is 90 degrees. All right, great. This is the angle in the semicircle. All right. So now we are told here to prove that angle A1 is equal to 90 plus E2 plus B1. Where's angle A1? This is this one. Okay. So what do we say, guys? This is the angle at center for this arc CD, and it should be subtending. Sorry. There should be subtending that angle at center and this angle at circumference. So this one must be half of that angle. Okay, cool. But we were told something, that these points D, C, B, and E are concyclic. It also means that this angle should be the same as that one too. Those are angles in the same segment subtended by arc CD. Or one can also look at it as that it is half of that angle. Angle at center 2 times angle at circumference, meaning those two are equal. So now we want to have E2 instead. Oh, right. Okay. All right. So how we're going to plan this is this way. I can already see this B1 is there. So I know that B1 is equal to that angle. But that angle is 90 degrees minus E2. So I can create something nice there. So how are we going to plan this attack? We can say we start with E1. We want to ensure that E1 is 90 degrees minus E2. So we're going to say, well, angle E1 plus angle E2, these must be equal to 90 degrees. That is the angle in the semicircle. Right. So therefore we want to show that E1 is 90 degrees minus angle E2. Okay, we already have a portion of what we want. It's there. Great. What are we going to say though? We're going to say but. So wait a minute. I need to say something interesting here. Let's say, well, we know though that, how do we start? Let's write, we know also that angle B1 is equal to angle E1. Right. What is the reason for these two? These are angles in the same segment. Okay, subtended by arc CD. We can say then, we understand that basically angle A1 is equal to 2 times angle B1. Right. Why? This is the angle at center equal to 2 times angle at circumference. Oops, this was supposed to be a circle. All right, yeah, a lot of theorems, ne? So this implies that angle A1 is basically angle B1 plus angle B1. Okay, easy stuff. So this implies that angle A1 is, what did you say? B1 is equal to E1. So this is angle E1 plus angle B1, which we can also replace nicely. So we can conclude actually here. Therefore, angle A1 is going to be angle E1, that was 90 degrees, minus angle E2, then plus angle B1. It's done. Okay. That was a bit nasty-ish. So it's a bit nasty-ish, but it's good. Eh? It's a good question. This is a typical higher grade question, because you need to plan nicely. And again, the gymnastics here are what could fool a number of students. They wouldn't know that you can actually split this nicely. So that was where the trick was, probably. How many marks? 6 marks. You win. This one and that one. This one. So 1, 2, 3, 4. This substitution 5, and that substitution 6. Okay, interesting. We move on. Easy 12 marks there. Okay, not so easy for the last one, perhaps. Could cause a few scares. All right, okay, all right. How many questions are here? 2. Okay, maybe let's go into the new page. Question 11. Now we said in the diagram below, CD and BE are chords with CD equal to what? So we know that equal chords subtend equal angles at circumference in the same circle, of course. But if these are in 2 different circles, then we're talking a different story. So be very particular about the information given. So if those 2 are equal, then they should subtend equal angles at circumference. Nice. And then we're told also that F is also a point on the circle, so that's fine. F3 equals X, okay? Not a problem. Now we are told that we need to prove that C1 plus C2, so meaning this angle, is equal to B1 plus B2. Okay, so how do we do that? Well, I'm looking at this. See this cyclic quad. This is a cyclic quad. And here's another one. So can you see there is another cyclic quad. So we've got two cyclic quads, the yellow one and the blue one. All right. So we can see that these two cyclic quads actually have this angle as a common angle to both of them. What color can we give it? Can you see this angle is common to both cyclic quads? So we can use it as a common angle to link the two. Ne? And after linking the two, we will end up where we want to end up. Because we know that if this is x, that should also be x. Nice. So those are equal. So we can use that F2 as our common angle to get whatever is being proposed. So let's see. Question 11a. Okay, so we know that basically angle C1 plus angle C2 is, this one plus the opposite ones is going to be F1 plus angle F2. Right. Equals 180 degrees. Why do we know this? We know this because these are the opposite angles of a cyclic quad. Can you see, guys, all these theorems we've been going through, they're coming back here. So this means usually the exam has a tendency to do this, to keep repeating itself in different ways. So just remember, they know you can't really have your brain split apart all the time. So they will try to explore the same idea much more deeply. So always try to use that clue. Of course, don't hold on to it, but just know it's there. Sometimes most of your solutions will circulate around the same ideas. Now, what are we trying to do? We want to find F2, right? Right. We will say, okay, all right, okay. So this implies that C1 plus C2, I'm trying to see now. What is cooking? Do I really have to do anything here? I'm trying to see, guys, what I need to do. Okay. Now we just need to plan it nicely. I want F2 out because F1 is X, so I can deal with that later. So let's just do this and say, well, F2, this implies that F2 is equal to 180 degrees minus C1 plus C2, okay, plus F2, not F2 but F1. Okay, we can leave it like this, it's not a problem. In fact, we can conclude here. We can say here also, we know that technically this angle B1 plus B2 plus this angle F2 plus F3 is also equal to 180 degrees. These are the opposite angles of a cyclic quad. Maybe we can name it CBEF. Perhaps we should do the same up there. That was CDFB. Okay, great. So we still want F2, so therefore F2 is going to be 180 degrees minus the sum of B1 plus B2. So plus F3. Ne? Right, so this implies that essentially 180 degrees minus the sum of C1 plus C2 plus F1 is equal to 180 degrees minus these ones, B1 plus B2 plus F3. Okay, great stuff. So we see that 180 and 180 is speaking our language, so they will do the honors and go. So what do we have? Now we have this situation of minus into C1 plus C2 plus F1 equals minus B1 plus B2 plus F3. So if we multiply by negative, remember this is maths, so we have C1 plus C2 plus F1 equals B1 plus B2 plus F3. Okay, we've got a story, but we know that F1 is equal to F3, right? Why? These are angles subtended by equal chords. Given CD is equal to BE. Nice. So this implies that C1 plus C2 plus, instead of F1, we're going to write F3, is equal to B1 plus B2 plus F3. Now we've got this one the same. On either side it will do the honors and then they go. Okay, therefore we can make a conclusion. C1 plus C2 is going to be equal to B1 plus B2. It's done. Okay, of course guys, there are many ways of killing a cat. As long as the cat is dead, it must dry, it must just die. Okay, so this is very important statement, and maybe to do this is key, this is important, this is key. 4 marks, and then equating these to 5 marks. And this one, 6th mark. The rest is the gymnastics of choice. Nah. 6 marks in the bag. No problems, no questions, we move on. I'm already feeling a little tired now, so we've got B. So B says in the diagram below, FB and CD are chords that intersect at H, okay? And then CB and ED are chords that intersect at A. Now BCD is 30 degrees, this one. And then DEF is 45 degrees, it's this one. Okay. And of course GB is a tangent, so tangents, they do tangent things. Tangents are doing tangent things. Okay, that's a tangent, but now we don't have a radius, we don't have any chords associated with it, so we can't use this tangent, can we? And then of course we're told that this angle is 65 degrees. So we're told to determine the size of F2. Where's F2? This one. Everything is not connected. You win. It's gonna be marks 6. Okay. How do we deal with this situation? All right. Okay, so we've got 30 degrees and it's not equal to anything that we can see here. Okay, so I can only say this looks like it's equal to B1, but how sure am I? Digerege, tama China. Digerege. Anyway, let me think, guys. Let me think. Okay, this one needs us to plan a bit because it's gonna cause us problems. It's going to cause us problems. Okay, folks, I think a construction is necessary here. We can't link anything here. A construction is a necessity because if we do a construction, we will then start to have a bit of a movement. How must our construction be? Do we join there? What do we get? If we join this, how does it help us? This angle equal to that, it becomes 45, but does it help me? It really does not. So I need to get here. So literally for me, folks, if I want to get into this triangle, so if I want to get into that triangle, I already have 65. I don't know what F1 is. But the construction that can assist me is to do a construction like this. I think this construction here, splitting here into there, could be useful, right? Right, okay, now I can't break it up because I've shaded. It's going to be ugly. Now here's the thing, if I draw that construction, do you see I split this B2 into this angle? And that angle, if you can see, this arc CD eventually subtends this angle and it subtends that angle. So this would be 45 as well. So those two will become angles in the same segment. But remember, at the same time, my 10-chord theorem will also give me this angle. That angle becomes that. So now I have this 45 plus 30. So I'm only missing that angle. So, wow, what a question. I've never really seen a construction being needed for Euclidean. But remember, guys, if when we're doing proofs, we can construct as long as our construction does not distort our diagram and all the other angles intended. It's legal. It's perfectly legal. Okay, we normally don't get to draw, but sometimes, as you can see, there's no way we can solve without a construction here. Okay. So to answer B, we will start by saying construct DB. Okay? And then, of course, it will be shown. So now we've got a situation here that makes life easy. So we just forget about B1 and B2 now, but we know that B2 is the entire angle that includes this and that, but we're not going to call it that anymore. But we can call it whatever we want, honestly speaking. So what are we going to say, guys? We will say literally, after the construction, we know that essentially. Now we come back, we say in triangle, We want to work on triangle BFG. So what are we going to do with triangle BFG? So we know and understand that angle D, BG is going to be equal to angle C equal to 30 degrees. This becomes the 10 chord theorem. And of course, this is combined with our construction, but we already stated it. You can say here also, we know that this angle F, BED, is going to be equal to angle E, equal to 45 degrees. These are angles in the same segment. Okay, and as guys, sometimes when I'm tired, my writing just dies with me as well, in the same segment. But I think my hand is tired. I have been writing for the past 10 years under pressure. My hand is really tired, guys. I need a serious break from this nonsense, but it's what puts the food on the table, so there's nothing I can do there. So can you see, guys, what are we doing? We can say here, therefore, angle B2, because this is angle B2, is literally equal to 45 degrees plus 30 degrees, which is going to be 75 degrees. Why we see this? We can just say C construction. The construction is like this. So that is what we do. We can say then, we know that angle F2, plus angle B2 plus angle G equals 180 degrees. This is the sum of three angles of that same triangle we're talking about. So this implies that angle F2 plus B2, which is now 75 plus 65 degrees, equals 180 degrees. Therefore, our angle F2 is going to be 180 degrees minus the sum of those two. And then get the calculator. Where is the calculator? Come on, calculator, open. Tlakwana. Hatamela mona. Ke tla dula ke rapela. Mona. Okay. Re dula re ntse re rapela re le jwalo. Let's do the calculation. 75 plus 65 is giving us 40 degrees. Is it degrees or is it degrees? Yonaleyo, guys. For me, I will accept the answer because it's an acute angle. It looks a little bit comparable to 30 degrees, so it should be somewhere there. And it looks a bit less than this one, so they're comparable. So we can accept the answer that, wait, whatever we did, it sounds right, ne? I think, guys, this is mark worthy because without it, there's no moving forward. And then, so this one is good, this one is good, and this one is good. So 4 marks already. And then substitution and answer. Yes. 6 marks. Nice and easy. So folks, This marks the 12 marks. Okay, this one was a bit of a scary 12 marks. It's not really scary. Okay, Soplexity-nyan. I think this one is also a definite higher grade question, because I don't think a standard grader would know they need to do this kind of thing, because we normally don't think of a construction in Euclidean geometry. So this was probably the trick. Otherwise, the rest was fairly easy. Grade 8 stuff. Okay. Now let's do question 12. Kantas Pele's questions. Hey, there's 13 also. Yeah, when? Hi, boo. Yep. This thing is long. It's long. Question 12. I think that's just ridiculous. The ridiculous amount of these questions is just a problem for me. Otherwise, I don't find any difficulty in this thing at all. You see, maybe this one, maybe the last one also. You can say higher grade. There's nothing here, nothing there. There hasn't been much, eh? All of these questions were fairly easy, except when we got here. Yeah. This one was a bit naughty. This one naughty as well. Naughtiest, if at all. Okay, let's see question 12. It says now in the diagram below, A and B are the y and the x intercepts, respectively, of line y equals 2x plus 6 minus 2x plus 6. Okay. Oh yeah. So this is definitely the line that we are talking about. So this is already giving us the coordinates of B. When we make y 0, this becomes minus 6 divided by minus 2. This is 3. And 0, and that means A is the point 0 and 6. Nice. So that is the story being propagated, but we'll have to justify that, of course. And then AB and BC are tangents to the circle. Okay, so nice. We know that tangents are equal from the same point to the circle. Okay, not a big deal. And then T is that point. Okay, we're given the points of tangency. Not a problem. Great. So if I can just imagine my circle center to be here. Does it look central? It should. And then, of course, if I draw a line to that, and a line to that too, that should give me stuff like the stuff that I know. So those should be perpendicular, right? Because we know tangents are perpendicular to the radii. That's if this is the radius. I mean, that would be the center. We can call this center. I mean, this is the origin here. We can call this center. We've got PT. We can call it S. It's not a problem. Now, what can we do with this, folks? Okay, let's leave that for now, because there's not a lot we need to do technically, because we could actually determine the equation of that line. We can actually determine the equation of this line, and where they meet we can find the center. So it says now determine the equation of the line passing through P. Determine the equation of the line passing through P and the center of the circle. So can you see? This is the line. This is the line. So basically, we want the equation of the radius of the circle. And we know that the circle center, the radius and the tangent are perpendicular. So this is easy. So we know that the gradient of the line multiplied by the gradient of, let's say AB, must be equal to -1. We know that the tangent is always perpendicular to radius, né? So therefore, or let's be kind. M line into -2 is equal to -1. Therefore, the gradient of the line is going to be 1/2. Great. So we've got the gradient, so we can say then the line is such that y equals 1/2 of x plus c through point P, which is 2 and 2. This means 2 is equal to 1/2 of 2 plus c. Therefore, our c, this is 1, and this is going to be 1. Okay. All right. Okay, therefore y is equal to 1/2 of x plus 1. Okay, that should be easy. So, what are we going to say about it? We are going to say exactly what we are going to say. We are going to say exactly what we are going to say. How many marks? 3. Easy. Okay, gradient, important, substitution, and the final answer. So that is 3 marks. Okay, not a big deal. Now B says we want the minimum distance from the circle's circumference to the x-axis. Wena zingaphi marks la? 7. Yo, ke ngwe taba jwale. Here's another story, this one. Sorry guys, we want the minimum distance from the circle circumference. Okay guys, so obviously we need to find the lowest point on this circle. Which one would be the lowest point? Could it be this one? But this point is below that one. Okay, great. Let's just do this. If I do this from this point, I draw a line parallel to the x-axis, meaning perpendicular to the y-axis, like that. Of course, now I'm just planning my attack, guys. Sometimes some questions need a moment. You can't rush through those questions. If you do so, you are committing what is called suicide. Now, this is me trying to find another point that would be the mirror image of T on the circle. And I can clearly see that this particular point I'm looking for is a point like this. This should be a point between these two. It should be here somewhere. And that point to the x-axis would give me the minimum distance. Okay, so that is what I think I need to do. Now I need to find what is cooking there. But now, there are many ways of killing a cat, guys. So what I'm already thinking is I need to find the midpoint of this line right here. If I find a midpoint of that line, I would be good. And obviously I know that at this particular point right here, the y value must be the same because this line is parallel to the to the x-axis. So I know that this is 1, but I need this x value there. If I can find that x value, then I can actually find the midpoint, because the midpoint between these two will give me the lowest point on that circle. And from there, I know the x-coordinate, I'll find the y-coordinate. And the y-coordinate is going to give me that distance. Yeah. It looks hot, 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 hot. Now, is there any algebraic means of doing it? I don't know. I do not know. Now I'm trying to think also. But it would be a lie. If I say this line passes through the center, what would be the reasoning? Because if I could say that, then I could say the radius of the circle minus whatever is on this point, but I don't see it. I don't see it. But now, guys, what I think, I need the mirror image of t along this line so that the y value is 1. Okay? If I've got the y value of 1 there, I can essentially find what would be the x value there. Is it the same as b? It looks like it though. But we can't say. We can't say. We can't say. All right. I don't know what to think. Was there more I'm given? So this means I need the equation of the circle, basically. And then I find the midpoint of this line. If I can find the midpoint of this line, okay, we called this one S, we can call this one Q. So we can find Q there, because that midpoint is going to give me the lowest point on this circle, and the lowest point is going to be exactly what I want, because you can see that from this point T, the circle is climbing. So beyond this point T, the circle is higher, and that would mean also beyond this point, the circle is high. So the lowest point should be halfway between these two, because that would coincide with the lowest point ever. Ne? It looks like that is the plan. But now, how are we going to do this, guys? Yo. Hey. I feel like I'm burning, guys. I'm trying to think. Yo, this question. Ifasile. Yeah, this one is a proper higher grade question now. This is something you would call complexity. Not all these other questions. This one is a proper complexity. I'm trying to think, folks, what would be the best way to deal with this question so that we do not have a problem. I'm trying to think. You see, this tangent and that one also are doing their own thing. Okay, guys, I need the equation of the circle. From the equation of the circle, I find this coordinate here. From there, I find this point. From that point, I then find the corresponding y value on there. And that corresponding y value would be the shortest distance. I think enough is enough now. I can't think until Jesus comes. I have to do something. Now, how do we find the equation of the circle? We don't have the center. Yeah, when? I use it as means, innit? Our problems are many. Okay, guys, yeah, this one looks like an essay. Yo, hippie coke, I'm out in sale. Let me put the light on. It's late already. Okay, guys, this question is doing stuff onto me that I don't think I like and appreciate, you see. I don't appreciate what it is doing to me. So now I'm thinking, guys, what I need to do is to find the equation of, the coordinates of the center first. And now what will help me find the coordinates? I already have a line. I just need this one. Because if I can find this one, I am home free. I'll find the center, then the equation of this one, and then from that equation I find that one. From that one I find that one. So what are we going to call this point? We said this one is Q. We can call this one R. Okay, so there's a whole lot of things we need to do. But first of all, let's just say let S be the center of circle. All right. Now we can deal with this. So we know that the equation of this line, TS, we know that the gradient of TS is going to be multiplied by the gradient of BT. Must be equal to -1. Now we know that, well, the tangent is perpendicular to radius always. And then what are we going to do? We want TS, so the gradient of TS into, we can say this one is 1 minus 0 divided by 5 minus 3 equals -1. Therefore, the gradient of MTS is, now let's see, what is this one? So this is 1 over 2. Yo, ziyafana. That means this line is parallel to this one. So those lines are parallel. Could we use that to our advantage? Okay, let's just go on. So this one is going to be essentially -2. So this is also suggesting that that line is parallel to that. So this is nothing but this is nothing but a square now. Okay, anyway, so this implies, okay, what do we say now? We can say then TS as a line is y equals -2x plus c. So through point T, which is 5 and 1, this means 1 is -2 into 5 plus c. Therefore, our c, this is -10. That side is going to be 11. Therefore, y is -2x plus 11. Easy, ne? Now, we want the center. So we can say, okay, all right. We can say now at S, it is such that we equate the two. Now we're not going to tell stories here, minus, okay, plus 1 equals -2x plus 11. I think we ran out of stories to tell now. Oh, right, which implies that, so this is the point of intersection, point of contact of radii, because these are the lines of the radius, right? Right. And then we transpose this to that side, so this is going to be 4 plus 1, that is 5 over 2 x equals, we move this one to this side, it gives us 10, and then cross multiply the 2, that's 20, divided by 5, that's 4, therefore x is 4. Okay, so x at s is 4, so necessity, therefore y at s is going to be minus 2 into 4 plus 11. Now 11 minus 8 is 3. Okay, that is above that point, so that we can accept. So we can say therefore the coordinates of S is 4 and 3. Okay, that makes a bit of sense. You can see that this is definitely ahead of this one and before that one. Okay, now we have found this one. Could it be? Is it possible? Is it possible? I'm trying to think, guys. Here when I think this is done, God. Don't you think, guys? I think this is the one. I think this is the one, because you know why? You know why this one should be the one? This one should be the one. The reason for this to be the one is the fact that if we say this is the most direct distance that we can get, because I mean from the x-axis this would be 3 units up, okay? That is the most vertical distance because the others are slanted. But now, yeah, no. Hey, let's not rush sometimes. But my worry is that I'm not going to be able to find this so easily. Ish. But guys, am I wrong? But I feel like the most direct distance there is going to give me the lowest distance here from the center perpendicular to the x-axis. It should be that distance. Yeah, man, all the struggling is not necessary. That should be the one, because if that line is perpendicular to the x-axis, that would be the most direct distance from the x-axis to the center. And we can see that every other point from there would be climbing. The y value for that would be bigger than that. That is what I'm thinking. And if I'm not thinking the right thing, then it's bad. Yeah, this looks like is the one, guys, but look, we didn't justify why B is like that. Ish, you see now. We did some crimes now. We can say here 2 also. We know B is going to be 3 and 0. We can say this is the x-intercept of AB. Did I say it elsewhere? No. Okay, so maybe we have to say that because we used it here now. We cannot use what we did not justify. It has to be justified. Now, folks, I am thinking, I am convinced, and I don't know if I'm right or wrong, but my brain tells me that the most direct distance from the x-axis to the center will pass through the lowest point on the circle. As we can see here, that even if we try to approximate that, if we draw some mirror image where this is 1, the midpoint is where this line should pass, and this looks like it's doing exactly that. Of course, this is not drawn to scale, but these are some of the questions you just don't know. So already, guys, what do we notice? We notice that the distance from the x-axis to the center is 3 units. All we have to do now is to find out what would be that small distance now, because that small distance is the one that we want, is the one we want. How are we going to get it? That is another question. So we have a lot of issues to deal with, folks. I promise you we have a lot of problems. Now I'm thinking, we found out this line, didn't we? We did not. Yeah, this question can't even land. This question. Yeah, this question is hot. It doesn't play. This question doesn't play. I promise you. This question is not playing. Oh yeah. No. Okay, now we know that this whole distance is 3, né? But then what is the radius of this circle? The radius is that one. So our job now is to just take the radius out, because if we take this dude out, if we take that dude out, then we have our distance. So we need to find the radius, and now the radius is just the distance between that. Okay, we can use our distance formula. So this is cool. So S is 4 and 3. Né? So this is what we need, because if we do not get it, we are in trouble. Okay, guys, we can do it. Let's just finish this question. I don't know why I'm sweating. I like questions like this because they just poke you a bit. We can say, well, okay, PS. Oops. We can say, however, PS is equal to the radius, or maybe let's just put it this way and say the radius of circle is equal to PS. Ne? This implies that the radius circle is equal to the square root. We use the distance formula. Now let's see, what is that? Y at S is x at S, it's 4 minus that at P, which is 2 all squared, plus this one is going to be y there, it's 3 minus 2 all squared. Therefore the radius of circle okay, the radius of our circle is going to be what we get over there. So let's do it. Square root of 4 minus 2 all squared plus 3 minus 2 all squared. I'm getting square root 5. Units. Now guys, we can see that if we take out the radius, we remain with our minimum distance. So we can say therefore, or maybe then, did we use that? We did. Okay, maybe let's just conclude. We can say therefore the minimum distance is going to be the whole length from the x-axis to point S. That would be 3 units minus this radius right now. Okay, great. Or we can say minus the radius and then we substitute. Do I really have to say it minus the radius? This is equal to 3 minus square root 5. So this is going to be essentially the thing is. But now we were told here to round off to the nearest. I mean, we can do it 3 minus square root 5. This is 0.8 units basically. Remember, no one said to what decimals, so this is 0.8 units. Okay, that was a naughty question. Okay, naughty, but nice, because yeah, it's doing the things. Remember guys, what makes me realize or understand that this line is going to be basically the one, it's because what I did, you see my plan, if this is to be the axis of symmetry of this one, right, this line here must be perpendicular to the axis of symmetry. And if it is perpendicular to the axis of symmetry, and I can already see that this is already a horizontal line, this must be a vertical line. Okay, so yeah, it looks like it's working. Of course, these are some of those questions that sometimes students would die. But here's what I can tell you. Even if you didn't get here, if you got here, you've got most of the marks, because that's where the bulk of the question is. And it's easy to think about that, because you would think about finding the equation of the circle. At least this would be one of the steps. But then as you go along, you're like, hold on, I don't really need the equation. I can just play with the numbers using analytical geometry. All right, okay, all right, guys. So this point is important to get. And this substitution is key, and this gradient is key. And this equation is key. So 1, 2, 3, 4. 5. Okay, maybe we're not giving so many marks here. I think this was a means to an end, so it's no longer a mark. So we've got 1, 2, 3, 4, 5, maybe 6, 7. Very interesting stuff here. Very interesting stuff here. All right, okay, all right. So please guys, double check this one. I'm not too sure if my idea here is making any sense. It's making me question my approach and my technique. I'm feeling like, but what if this is not the axis of symmetry of this line? Why am I making it 1? Yeah, it's one of those questions. Hey guys, is that correct though? Yes. I am not so sure of myself anymore here. This is a proper suplex. Telling her to fumana nestar ezimbini ngaphezulu. I think we're a bit naughty when. Now guys, I'm not convinced of my technique there. Yeah, you double check this one on the memo, please. Please check the official memo and see if what we did here is proper. Because if what we did is improper, then it means we may have to look at it again. But I'm trying to think. I don't see a better way. Because the most direct one would be this one. And if this is to be perpendicular, parallel to the what, then these two are perpendicular, and essentially the line that would bisect this RT of ours should be a line perpendicular to it. And since these are already perpendicular here, it is suggesting as much to me. So I'm quite convinced that this line being a perpendicular bisector of that line, it definitely would give us what we want. Okay, let's leave it at that, folks. Sometimes you never know for sure. You just go with the flow and hope for the best, you see. Yeah. Sometimes you just hope for the best. Please double check this last one. I'm not so convinced. But I'm convinced. Actually, I'm convinced. Looking at that, I said I wanted a line horizontal, meaning parallel to the x-axis, and therefore a line that would divide this into two would be the perpendicular bisector there. And for me, this looks like it would be such a situation, you see, because this is going to be hectic. I can't find R. But I can find R because, I know the y value is 1. But then it would force me to find the equation of the circle. But hey, that's a lot of work. But do it if you feel it is the way. But guys, I'm stopping there. But I'm feeling like, this question, what is it doing to me now? But I think my plan is working, guys. I think my plan is working. So okay, that was a moment of silence, right? There's question 13. These guys are crazy, They are not serious. Question 13. Okay, let's do it, guys. This is revision. You can't cry. Revision must be revision. Now, a teacher creates two circular areas in her classroom for toddler A and B, okay? The first area for toddler A is labeled by, can you see this is an equation of a circle? And then the second area for toddler B is this one. Okay, this one is in standard form. This one is an extended form. So we need to complete the square there. If we complete the square, this is going to be x plus half of that, 1, all squared, plus y. Now this is minus 1, all squared equals. Now this is basically 1 squared, which is 1 plus 1, that's 2. 2 minus 1 is 1. So the radius is 1. It's a standard circle. So that's the one. Now it says the teacher claims that the playing areas will never touch or intersect. Is the teacher's claim correct? Okay, all right, okay. Now we need to find the distance between their centers, because if we can find the center there, then maybe the center there. Now, if we look at their distances, we can say AB. If this AB is greater than this radius, you can say this is R1 plus R2. Then indeed, they don't touch. How many marks is this thing? 5 marks. It's not too bad. Okay, we can start here and say, well, A, we can say let area for toddler A be such that it's circle A. Okay. What am I gonna say? We write it. This is x squared plus y squared plus 2x minus 2y plus 1 equal to 0. I can write it properly. This is x plus 1 all squared plus y minus 1 all squared equals 1. I don't know why I'm saying this. I don't need to say this. We can say circle A. Don't need to say a lot. We bring it here. That is circle A. And then we can say essentially circle B is such that x minus 3, or we can say therefore the center A is minus 1 and 1. And the radius is 1 unit. It's the square root of that. Oops. Now this one, so I can say therefore the center B is 3 and 4. And the radius, maybe say RA. So RB is going to be 2 units. Okay. So what do we say? We can say, well, let's look at AB. We can say now AB is the square root of x at A minus x at B all squared plus y at A minus y at B all squared. Oh, I'm tired now. X at A is minus 1 minus 3 all squared plus y at A it's 1 minus 4 all squared. Let us see. Now let's see. So square root of minus 1 minus 3 all squared plus 1 minus 4 all squared is 5. So this is 5 units. So let's see. That's what we wanted. We can say also, we know RA plus RB is going to be 1 plus 2, which is equal to 3 units. We can say since, or maybe we can say therefore the two circles A and B do not touch. The reason is, okay, since AB is greater than RA plus RB. Nice and easy. Okay, very nice question. A very nice question. Normally, this is one of those higher order questions as well, but it's not too bad here. So what was important was to write this circle in the right format and to get the center here, and here it was just to get the center there. So this is 1, 2, and then 4, and then 5. Yeah, that is what I can see we needed to do. And of course, the answer does not necessarily get a mark, isn't it? Yes. So there we go. There we go. Okay, let's finish this thing, guys. It's too long now. It's too long. Okay, let's move on to B. All right. Okay. All right. So this is B. How many marks is this? 6 marks. Getting with up. Okay, in the diagram below, the circle with center A has a radius of 2 units. Okay. All right. Okay, so we know that this is 2 units. And that is also 2 units. Okay, great. So this is 2 units. I'm just going to write 2. Now, we are told this is the center, of course. Now, and touches the x and the y axis. So now if it touches the x and the y axis, it means these ones become tangents. So if we extend lines to that, because once it says touches, it means this x and the y axis, they become tangents. Okay. Now let's see, if the area of the quarter circle, okay, the area of the quarter circle, FEG, what is it, or FEG, so there's a big one there. All right, okay, all right, is this one. Calculate the perimeter of the rectangular space ABD. Okay, this one is kicking us in the face. So we have this. Okay, so we've got that situation there. So now what do we do, guys? So if this is a quarter circle, this means these two are at right angles. So we've got a right angle there. This is what we are getting, okay? Did we read the whole thing? No. Goodness, I jumped around. Okay, BC is the tangent to the quarter circle. So BC is the tangent to the quarter circle. And if it is the tangent to the quarter circle, this is going to be 90 degrees. Okay? And then of course, if we are told this is, okay, let's go on. BC is a tangent to the quarter circle with center F. Now we are given the coordinates 5 and -1. Okay, right. Now, what can we do? FAB is a straight line. FAB, okay, that's fine. Now the length of AC is 11, square root 11 units. Okay. Not a problem. Now, okay. We're told if the area of the quarter circle is, calculate the perimeter of the rectangular space. Okay, now, what I need okay, guys, let's think about it. So we've got 2 units here already. And then we can actually find the radius of this one. Ne? If we find the radius of this one, and then what are we going to do? Uh, 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 uh. Mm, 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 mm. Eish, guys, telling a different any question go. Why does it look like it wants to be too forward now? My coke is finished. It looks like it wants to be too forward, folks. And I don't think I appreciate that. I really do not appreciate a naughty question like that. All right, okay, all right. I just do not appreciate this. Can't appreciate this. You know this. Okay, all right, okay, guys. So I'm going to plan this one nicely as well. Let's first find the radius of this quarter circle. So if we want that, we know that, well, we know that a quarter of pi r squared is equal to 8 pi, isn't it? This is what is giving us, because a quarter circle is going to be like that. This is what we are given. So we get r squared is equal to 8 pi divided by 1 over 4 pi. Ne? Actually, you know what? Let's not be ridiculous here. The pi will, if we divide by pi, it's already gone. So r squared is going to be 8 divided by a quarter. Maybe let's do this so that we don't run into problems. So this implies that r squared is, now 8 by 4, this is 32. Okay, therefore r is going to be the square root of 32 units. Okay, so this is it. We wanted to find out what that is. Now that we know what that is, what are we going to do with it? What are we going to do with it? With it? Now I'm thinking, this is this distance we just found, folks. It's that distance. Now, what can we do with that distance? What can we do with that distance? Because okay, now I see what is missing. You know what was missing here was for me to drop this one like so, and drop that one also. Because remember, these are tangents. Tangents. Now, if these are tangents, and then of course we do what we do best, what do we see? We will see that if this is 2 units, then it means the y value at the center is 2. And then if that is also 2 units, because remember this is the origin, the x value is also 2 units. So we're being given the coordinates of A indirectly. So the coordinates of A are given indirectly, knowing that the tangent is perpendicular to radius, and knowing those units vertically like that is already good, because these are already. Now, what can we do with all of this already, Stuart? Because our intention to do this, get what we need. But I don't see why I'm getting this. I'm getting a bit of a problem. So let me charge my things before the power cuts. You know, sometimes the power just gets cut here and stuff happens. Okay guys, but anyway, I think the coordinates of A are going to help us to find FA, right? So if we find FA, what are we going to do with it? This can help us find this distance right there. This one will help us find that distance, because if we find FA, if we find, we know the radius FB is this one. So if we subtract FA, we have this situation over there. And we're already given AC, so we can use Pythagoras to find BC. Then since this is a rectangle, we know the opposite sides are equal. Opposite sides are equal, so this is going to be good. Well, that would give us that. Okay, and then using this small piece of a triangle. So if we use this one, we will be able to get our stuff nicely. All right, so let's find out. We can say here, the center of circle. We can just say center of circle A is such that A is 2 is to 2. This one is logic, guys. I don't know how to explain it, but we know that technically if this touches the x-axis, and that would be 2 units. So it makes sense for that to be the case. Make those constructions. Someone will understand. I don't think there's a story to tell here. What are we going to say next? We can say, look, if we want BA, we know we can say, well, also, we understand that BA is going to be FB minus FA. Of course, this is obvious on the sketch. This implies that BA is FB is nothing but the radius of the quarter circle. So this is square root 32 minus FA. We will have a situation here, so I'm not going to waste time. Sorry, FA is going to be X there, 5 minus 2 all squared into minus 1 minus 2 all squared. Therefore, BA is going to be the square root of 32 minus, let's sort that one out. So square root of 5 minus 2 all squared plus minus 1 minus 2 all squared. So this gives us a 3 root 2. Could I show this one as a 32 is what? Is 16 by 2. Yeah. So this is equal to 16 is 4 root 2 minus 3 root 2. This is going to be root 2. Now, yes. Square root 32 minus 3 root 2. Yes, it's root 2, this one. Okay, root 2 units. Okay, great. Now, from those two, that root 2, so I know this is already a don't, but now I want BC. So let's get BC. we can say here, then in triangle ABC, this triangle ABC has been coming up nicely. What are we going to say? Maybe we can just jump in and say, in triangle ABC, what do we see? We didn't use however. We can say however. In that triangle, yes, sir. In triangle ABC, what do we see? We know that essentially ABC should be 90 degrees. Why? The reason is that we were told BC is a tangent to that circle. So the tangent is always perpendicular to radius, okay, of quarter circle. We can leave it at that. We can say then we understand that basically AC squared equals AB squared plus BC squared. This is from Pythagoras. Right. This implies AC, we were given root 11. AB, okay, maybe let's put it this way and say AB instead of BA. Okay, so AB is square root 2 all squared plus BC. BC was given to us also, wasn't it? Oh, it's what we want, sorry. I'm losing my mind. So this implies 11 equals 2 plus BC squared. Therefore, BC is going to be the square root of 11 minus 2, which is 3 units. Because 11 minus 2 is 9. Right? Right. And then the square root of 9 is 3 units, you see. Great. Now what are we going to do? We can say, therefore, perimeter is going to be 2 times BC plus 2 times AB. So this is going to be 2 into 3 plus 2 into AB. Now we can just punch it onto the calculator and sort it out. So this is 2 into 3 plus 2 into square root of 2. This is the one. So we are doing 2 decimal places. So this is, 1 decimal place. This is 8,8 units. Okay. Because the question said we must do the perimeter. Okay, maybe let's move this business right there. I want to move these ones. Yes, I'm thinking why kunezinto ezishiyekelayo ngoku? Okay, let's do this before it drives me crazy. Feeling a bit dizzy. Perimeter of ABCD. That's what I wanted to say actually. Nice. Okay, that was also a bit of a complexity, if you ask me. It's not one that you can just run with. without thinking your way through a bit. As you can see, it's a bit naughty. It's a bit naughty. Okay, what are we doing here? How many marks? Can you see? We were supposed to show everything. Okay, all right, okay. So obviously, folks, I do believe this is good. How many marks is this? 6 marks. Okay. Now let's see. This is 1 mark, and I do believe this one is key. Is that so? Yeah. And this one is key. 1, 2, 3, 4, 5. 6. We can't mark it like this then. We can't mark it like that. 1 mark for the point. So it's going to be 1, 2, 3, 4, 5, then 6. Yikes, that was terrible. That was terrible. So of course, guys, on this one we get our 11 marks. That was a bit painful. For a grand total of 200 marks. Okay guys, I hope you enjoyed the video and you have learned something. As you can see, some questions, I think the last 2 are the big boys and girls, and of course there's equivalence to these kinds of questions in the DBE, so I don't think there's anything out of the ordinary here. There's always questions that force you to think. But one question that makes me shaky is this one. Please, folks, double check this last question here. Just find this memo and check if what I did is correct. But I believe it should be correct, you see. Otherwise, shisampam. Anyway, folks, that was me trying to give you a bit to work with so that you can get those marks. I don't know when you guys are writing your maths paper too, but I'm throwing it out there so that you can practice, even for my DBE students who are going to upgrade next year. This question paper can come in handy to practice. So please do yourself a good and justified, exercise here. Pause the video on each question and then try it out first. Get stuck, look at what I'm doing, and then after that you can even double check where I am not so sure with the official memorandum. In case I am making some crazy errors, I have a tendency to do that because you know what, there's so much imperfection in this perfection. So you will see that it's not so nice sometimes. It's not so nice. Sometimes it's very confusing, but hey, you roll with the punches. You guys let me know how you feel about this, but my verdict is IEB is not any different from DBE. If at all, it's much easier than DBE. Because, let's be honest, guys, we looked at how many questions that were really, really, really naughty here. Hardly any. Most of it's just that there's too many questions, I guess. There's just too many questions on this thing. But I don't think these questions were of any difficulty whatsoever. But of course, if you don't know maths already and you don't practice some higher order questions, this becomes a nightmare for sure, because already you're chased away by the fact that time is against you. But if at all, I can say that typical higher grade questions here, this is a low-key higher grade question, to be honest. It's a low-key higher grade question because you wouldn't understand what's going on in here if you don't integrate. This one is a low-key higher grade question. Maybe this one also. No? This one. This one is also a low-key higher grade. Yeah, most of the questions were straightforward up until those. And then we moved on. These ones were fairly easy. Perhaps this one, yeah. Maybe this one also. Simultaneous equations, it's also higher grade. Okay, you're right. Why do we not qualify this one as such? This one was a beast. An absolute beast. Especially here. I'm not even sure of my answer. And then this one is a fairly standard question. I wouldn't really give it much. Yeah, this one was a bit silly also. So yeah, I mean guys, this is an equivalent of your DBE, because in DBE you always have a very higher order question in statistics, usually the last question. You have a higher order question in analytical geometry, question 3. This is usually the last 2 questions there. And you always have a bit of a challenge with the circle question, which is the grade 12 component. Sometimes it can be most of the questions there. Sometimes it can be just one question. It just depends. But there's always a higher order question there also. Trigonometry, there's always some challenges lying somewhere somehow, you know. So again, Euclidean geometry, we know that the last question, question 10, usually has suplexity in it. So all I can say is that, would you really say IEB is tougher than DBE? No. For me, they are the same. And in fact, most of the questions in here, they look a little bit less challenging than you sometimes find in the DBE. But again, you can't say based on one question paper that is the case. It depends on the overall. But I mean, even from my experience when I was a student, IEB question papers have never really been difficult for me not to attempt fully. When I got a hold of those, remember there were those government books, you know, they used to be blue or so. They used to have some past exam question papers. They would have, for paper 2, you would have 2 questions from DBE and 2 questions from IEB. I often found difficulty in handling the DBE ones versus the IEB ones. I would always score full marks, 100% there. So, I don't know though, things may have changed. But from what I see, I don't see much of a change. If at all, I would say these 2 things are similar. Just depends on how you want to look at it. Anyway guys, before I start saying more than I'm supposed to, hope you enjoyed the video, and this is just a gift for those who want to practice for next year. And for those who want to upgrade next year, this can be a good look into how questions can be asked. As you could see, that there were some nicer questions that you normally don't see. So the way in which they were asked, it really propels the idea that you need to really practice even IEB papers if you are doing DBE, so that you can have a wider range of knowing how to do things. In fact, also see how widely questions can be asked about a topic, so that your knowledge is very clear and solid. And so you go into that exam with your head, not with panicking. Of course, anxiety is part of the game, because I mean, you always wish, I hope that everything is what I studied, or at least whatever comes out is something I can handle. The anxiety will always be there. But you would know for sure though that you cannot say you did not study well or you did not prepare well. You have done your best. And of course, good luck guys to those who are writing IEB Maths Paper 2 soon. And I hope this video finds in good time. Otherwise, I'll see you some other time. Goodbye.